Because what we realized the other day, definitely you should have many questions, but when only one question, I think Nadun, right? Nadun here? Yes, Nadun, when he's asking, it's not the real thing. Maybe he may not be able to, convey your problem, right? Who knows, right? I mean, you should learn how to raise a question, right? Nothing to worry. Definitely, you may do many mistakes, but that is, the starting point of learning. You must ask questions because it totally depends. I don't know what I'm telling you is the same way that you're going to pick them up, or vice versa as well. Or else maybe I don't know whether I'm delivering it okay or not. Right? Only through a question and answer session we will be able to fine tune that one. If we keep quiet and we keep delivering the lecture, there's nothing happens. Don't postpone it, don't delay it, right? Definitely there will be thousands of questions that you may need to ask. Maybe you are reluctant because you are not practiced to do so. At least you should take this as a best opportunity. Right? Raise your questions. At least in a small group discussions, you can ask questions. Right? And also you read about additional thing. This is design. Design cannot be, I hope if I continue it's okay because others are not yet here. I mean, design cannot be done based on the books or the equation written on books or just following books. You need to learn what happened in the past. Experience is more important thing. Maybe not only your experience, the experience of others as well. You have to be very active in this field. The developments are there. New tools are coming up. Maybe the existing things may be no longer valid. New regulations are coming up. Everything changes. Material is changing day by day. New materials are coming up. New manufacturing, machining, and fabrication technologies are developing. New products are being developed. Patents, how many patents have been registered within a day? Maybe not in our country, maybe in other countries. And not only that, they don't stop by registering your patent, but also they continue to convert that one into commercial products. Right? How many research work is carried out on these things? Sometimes, say for example, this modeling alone, there are research going on. Right? The modeling techniques. Now modeling, the technique whether you apply this one to one area and maybe to different areas as well. It's very dynamic. You should be able to understand, and even the technology is developing. You should be at least, I mean, in touch with those things as designers, as mechanical engineering designers especially. Then only you feel comfortable. Otherwise, you start trying, all these traditional, conventional ways using those equation and other things given in what is this book is Kurmi and Gupta or the other one. Right? Those things are okay. There are two sides. Now, when we are learning, we have to test your knowledge as well. Yeah, your theoretical knowledge. For that, of course, we set question papers and other things. But once you go to the field, once you go to the industry, even want to start doing research, those set things will not be there. Everything is new, everything is unknown. Complete darkness, you have to find your own way. Right? How do I do that? You can't ask from someone else because who knows, maybe he is going to give you some advice without knowing what exactly you're asking. It is your decision always. Right? In order to make sure that my decision is correct, then I have the confidence. I have to have the confidence. I need to build up that confidence. Otherwise, it's going to be difficult. Don't think that we will not do any mistakes. Or I mean just shame of doing mistakes or something like this. No. Even the world famous things, companies, organizations, they do mistakes. You read newspapers and the internet maybe articles. How many times the world famous car brand, the Toyota, has recalled some of their products? because there's a design fault, maybe manufacturing fault, something else has happened. So you have to accept all these things. You have to accept all these things and then work on that one to not to happen the same mistake again and again. Right? So don't try to fix everything. Today, if you decide something, maybe tomorrow I need to change it completely. Or maybe day after tomorrow I need to drop the idea completely. Who knows? But you need to prepare to work. You have to prepare to work. So that is why we don't like you to, keep postponing things. Because towards the end, we don't have time. Our schedule is controlled by the entire university. So we have to abide by the deadlines and other things. So in that case, you may have some difficulties. You need to, get used to kind of a tough life. Life is tough anyway. You learn engineering and then you practice as engineer means life is tough. It's not easy money anyway. Right? It's not easy money and the responsibility is on your shoulders. Of course, you can forget all these things and then get a nice job with your, the qualification and other things and then stay quiet. But that's not engineering. We should not do that, especially mechanical engineering. There's always a challenge. There's always a challenge. 76 students are still here. Right? Now, you might be thinking this is additional. Of course, there's a lot. What I'm trying to cover is the most basics, give you some introduction, and then cover the most basic required to complete your project. But that's not all. That's not all. There will be even many more things. So if you start this journey, never turn back. No stoppings. Until you die, it will continue. So develop that kind of an attitude. Don't think that whatever that comes to you as a burden, then difficult. Then difficult. Some more to come. Okay, till others come, I will just give you kind of a summary of. Let me share the screen. I hope you don't see it right now. Can you see the presentation, the first slide on the screen? Yes?
Yes.
Okay.
Okay. Right.
So let me take you over to the something that I need to highlight to you. I actually prepared these additional slides based on the discussion we had, I hope, yesterday. Right? Those who are supposed to rule this product design and development in the semester 8, we will cover these topics again and again to understand what is design, right? Product design and development. Design and development. This is a very, very, very brief idea that I'm going to give you. And at the moment you are here in the detailed design part, you are doing the detailed design of something very specific. Right? You need to get input from previous stages. That's a quite long procedure, right? That's a quite long procedure. So you are in between. So we're going to give you the experience of the detailed design because that is actually more important. I couldn't say that anything is not important. Everything is important, but detailed design is where you're going to put the specifications, specifics, identify the material, sizes, and everything like this. So this is what you are doing at the moment. Right? This is what you are doing at the moment. And then I told you the other day, it's a teamwork anyway. It's a teamwork. So maybe your task is only as a mechanical designer, but there will be a lot of other people joining the team. You can't name it and you can't identify. Qualified person, unqualified persons, skilled person, unskilled person, everybody will be there. It's a teamwork. So you need to communicate among the team members and try to share your knowledge and other things. Then only it will be successful. So we are not going into that depth. Anyway, as a mechanical engineer, you should be able to, you know, perform your task, perform your role as an individual. Of course, you are a member in the team, but your task alone, you should be able to do it correctly. You can't be kind of an isolated person. You have to get advice from others. You need to give them advices, information, data, whatever it is, you need to exchange. Right? So this is the design process. And then just to give you some idea, some world famous products, just to get some idea. You see, starting with the Stanley Tools, one of the leading tool manufacturers in the world. You see, this example is given for a screwdriver. Stanley screwdriver is very famous. Right? If you ask from professionals, they will tell you. And just get some ideas, the annual production is 100,000 units per year. And the sales lifetime, you say 40 years. You need to calculate all these things, of course. Sales price is just $5, right? And number of parts, it has 3 parts. It's very simple. But look at the development time, it's 1 year. And how many people involved? Even for this small, simple thing, there are 3 people involved in that one. Maybe not all 3 people are from mechanical engineering. Maybe someone else as well. And also there are some external development team as well. And look at the development cost. It's huge. It's huge. And look at the other end, the Boeing 777. 50 units per year compared to the first one, 100,000. This is 50 years. And the sales type, 30 years. Look at the sales price. Look at the number of parts. 130,000. And the development time, 4.5 years. Sometimes Boeing, I think 380, it took almost like 8 to 10 years. The more importantly, you can see the number of people involved, 6,800 people. How do you communicate among 6,800 people and make sure that still you are not doing any mistake? And also external development, maybe outsource people, your service providers, your raw material providers, all these things, 10,000 people. Someone needs to manage all these things at different levels. And development cost is 3 billion. You can imagine. This is what you call the product development. And you are doing only a small piece of that one. Right? You are doing only a small piece of that one. We were all, interested in designing a gearbox for a car, an existing car. I got these pictures. Right? I purposely searched the internet and then I found these details. You see this Maruti, when it was started, and then the development history and everything. So your attempt was, I appreciate your attempt, but it was like too simple like thing. And for a product that the development has been taking over many years, within 1 semester, you are trying to replace its gearbox. Right? Yeah, you need to have that kind of a vision at the beginning. But also, you need to search for the information as well. What are we going to do? Maybe there should be a reason. For the students in my group, I advise them, okay, I'm not going to, take away your ideas, but anyway, you should be able to justify your selection. Why you do so? Right? Then you should have, because we discussed even the other day, there were like 4 or 5 speed gearbox, forward speeds, and then you are trying to replace with 3-speed gearbox. Why do you do so? How do you justify that? What will happen to the vehicle dynamics and then other design features and everything? If the the Maruti company knows about it, what will happen? Accidentally, you might take your report to a person who earlier worked in Maruti. There are people like this, right? Then what will happen to? They will start asking many questions from you. Of course, if you have justifications, valid justification, there's nothing to worry. But without that, for the convenience, if you think, okay, so this is like that, no. But still, you can develop a gearbox for a vehicle. So what you should do is, it should not mention as something already existing, but you can take some value specification from a vehicle. Your dream vehicle is not yet decided, no, not yet designed, not yet manufactured. So that is what you're trying to do. So you need to compromise, right? So this is what is important. This is the development, the product life cycle of the Maruti car. It's not the most up-to-date thing. Right? You can say 83 to 86, the introduction, 87 to 96, the growth, the rapid development, and then it matured in 97, and then start declining. Then once you have in that declining period, then you have to change your product, reintroduce the product as a new one. That's why different models are coming up every year. Right? So you need to understand these things. It's a long, long process. Right? You just cannot just within very few period, you cannot change this one. You need to understand these things. Interesting picture. Right? The first Maruti car. Even our country, we started assembling long ago. Right? But for some reasons, maybe the policies or whatever it is no longer in the market today. If you have done so, if you follow this one, then at least you would have been in a very nice place. There are a lot of people doing these modifications and other things in Sri Lanka. They're good, they're very skillful, but I don't know whether they are doing the right thing or not. Just by doing something, you cannot say it is the right thing. You can modify the vehicles, the body kits, everything else is coming up. But you need to compare that one with your original design as engineers. Otherwise, don't just evaluate the product only without looking at only the outer appearance, right? So this is, you should not be afraid of all these things. But anyway, identify your playing field and also the surrounding. Your spectators are just around. You need to have even some kind of an idea of these things before you start playing. You need to have your mental strength developed. Otherwise, you find it difficult, right? So with that, I think I will stop this additional introduction, and then I will go back to the beginning. So how many students are there right now? Only 80, still some more to come. Today, my plan is to just discuss about what we have learned the past two seminars. And then, of course, I will introduce more solid modeling tools and techniques. And then I will give a very brief introduction to synchronous modeling with solid edge. But don't get confused with the ordered modeling and the synchronous modeling. First, you have to absorb one, and then you're going to move on to the other one. Don't mix up. Maybe in this semester you don't have time unless you put some effort. But anyway, interesting things. And if time permits, I will just show you how you can customize the user interface as well, because it is also useful. Right? What you see on your solid edge screen may not be the same as when I open the solid edge on my screen. Could be different. Sometimes you use solid edge to do something, some work. So the interface is not prepared for that one. You always need to go here and there and then find out the tools and other things. So that way you can customize, so that it responds very quickly to your commands and other things. So I know that you're not going to ask questions, right? But anyway, I will not be able to, keep an eye on my chat box as well. I asked Dr. Leal, is volunteered to, get all these questions and then maybe compile and then raise some questions. Thanks, Dr. Leal. I mean, it doesn't matter. You can even ask, right? Even ask your questions as well. So what we have learned, just to remind you, right? Just to remind you what we have learned during the past 2 weeks, 2 semesters, and also at this moment, what you should be able to do. It's only learning, no? It's not enough. Now you should be able to do something. See whether you are developed up to that stage. Otherwise, don't delay it, right? Because something else will come tomorrow. This is what we're going to introduce as well. It's not going to take too much time because you know already. We discussed about the skills that you should have before beginning. My first lecture, and then the computer-aided 3D modeling. I gave you a very brief introduction of what is this 3D modeling is all about. You should know these things, otherwise you will just blindly doing something on the monitor, the computer, and then solid edge for 3D modeling. So in this particular seminar series, we're going to concentrate our discussion on solid edge software, and there are other softwares as well. So it's not the time for me to discuss about the other software as well. And then we studied a little bit deep into the process. This is very important thing. If you know how to control everything, then you'll be comfortable. But if you just practice by watching someone else doing this and repeating the same thing, taking down the notes and steps, you become very uncomfortable. Every time you feel uncomfortable. You don't know what is the next step. What is the next step? Now, when you start something, you should see to a certain depth. If you have experience enough, you should be able to see until the end. If you can develop into that stage, that's very nice. How do you develop those skills? Practice. Practice is the only thing. Nothing else. If you practice to a certain level, then it retains in your memory. If not, for the sake of doing this, for the sake of submitting assignments, if you do that, once you finish this one, nothing will remain because you don't have any interest of doing this one. Right? Interest of doing this one. And ingredients of modeling with solid edge. Identify some basic commands and tools available, very basic. And I would say your project of your design project, you could manage with maybe only the extrude command and the revolve command with some other few commands. That would be sufficient, of course. But going in a bit deeper is always advantageous. So if you want, you can limit your design to such items like extrude command and the revolve command. In that case, you should know exactly how to control the extrude command. What other features are there? Right? Now, for example, if you take a cylinder, you can draw a cylinder circle and extrude and get a cylinder. Also, you can draw a rectangle and revolve about one of its edges, and you still end up with a cylinder. And we're going to discuss about two other commands today, that is the sweep command and the loft command. The sweep command and the loft command both will provide you the facility to model a cylinder. So you have 4 tools to model a simple cylinder. So what tool that I am going to select? Is it the most sophisticated or the least sophisticated? Or the most convenient one or the most difficult one? What people usually do is you select the most convenient one or most easiest one or something that you can remember easily with less trouble, without comparing the tool with your requirements. Never learn that way of modeling. Always follow the easy method. Sometimes some software markets like that, compare the easiness and everything, but it is not what is required. It is not what is required. Those who have done the masters and then the postgraduate degrees and would say, especially these the finite element topics and other things, what we do at a simple software like this, or even Inventor or even SolidWorks or whatever it is, the analysis what we do is not really valid, and you can't control, you can't achieve your goals once you go into that deep. So always concentrate on that one. Match the tool with your requirements. Otherwise, you will find it extremely difficult. And also, we took some examples, and I went a bit deep even to tell you how to analyze the product, show you the options available for you to decide. That is the important part. If you can see all these things, not when someone is pointing you, but before that, if you can see all these options, depending on the product that you model, options can be different. You might have even new options available, or even based on the version of the software, you might have different options available. You should be sensitive to all these things, right? So when you work on a monitor, laptop screen is what I give the least amount of marks. It's not good suitable for 3D modeling. You should have a bigger monitor so that you can see the things very clearly. And usually 2 or 3 monitors, large monitors. I would say minimum say 24-inch or whatever it is. Why? Because you have that much of information. Right? So software will automatically condense its menus and other things when the screen is small. So then what happens? You don't see that. When you see something, you're going to get some ideas. Right? You're going to get some ideas. If you're not going to see them, no. Sometimes it is difficult. Most of the time it is difficult. Even experienced users find it difficult to handle the software in small screens. Unless you do, get used to do some presentations and other things from here and there. So then you are practicing only that. My point is that you should concentrate on the entire screen if you have on a single monitor. If you have 2 monitors, then you have to concentrate on all these things. The good example is driving a vehicle in Sri Lankan roads. Usually you should concentrate on front, but in our country, no. Except the top and the bottom, you have to see all sides. Right? Concentration. You should not respond, you should react. Sudden things are coming, panic situations will arise. Modeling is also like that. If you are sensitive to the changes which is happening in the monitor, means you are in the right path. Otherwise not. Right? So make sure that you have certain goals, maybe weekly goals, at least. If possible, you can have, say, daily goals. If you can set, that's good enough. And then it will be easy for you to reach your aim. Right? You will not be able to see the aim at once. And remember, your aim is not to complete the the design project and everything. You need to continue this one after this. All these, the things that you learn in the university, it's not going to stop or end once you graduate. Right? It will continue. It will continue. And this simple picture, maybe you have seen this one. I've slightly modified this picture actually. Do you see the person is in a very deep place and is doing something looks like a useless thing. Right? Don't ask me how he can find this pot for the watering and other things, but it's just to communicate an idea. Just to communicate an idea. And we have even a nice child song about this one also. Now you see what is visions? That's the same. That's the same. You should also have something like this. Otherwise, no point of doing what you call the modeling and other things. Remember, your aim is not to complete the project, right? That's a kind of a bonus that you can have. And at this moment, you should be able to define the design intentions, the scope, the flexibility of the model required, and where do I going to apply this thing, application of the part, and maybe something more as well depending on the product. The quantity required, whether it is in the initial stage, final stage, all these things you should be able to identify and define. Not all products will have that one because, say, for example, if the product is yours, then you can control all these things. Even if the product is not yours, you are working, you are looking at the product as an engineer. Then you should be able to at least visualize before you start modeling this one. You should ask from the customer, why do I need this? Why do I need to do? Why do I need this product? What purpose? Then only your thing you can apply it very correctly, and then separate major and minor features. You should be able to separate major and minor features. That's a very important skill. This is I'm talking about feature-based modeling, right? Ordered modeling. And then you should be able to identify the possible combination of features. When you see there are many features, then the next problem that comes into your mind is, in what order should I model them, assemble them, put them together? If I change the order, what are the possible consequences? Maybe not immediate, maybe at the end of the modeling, halfway through. Immediate consequences, of course, you can see. And some people realize this and then undo and then start doing some other ways without realizing what the mistake that you have done. This is called the building blocks. Features means the building blocks of your product. And select a suitable combination of features and their order. You can identify different combinations of features, and then you should be able to combine them if necessary, and then decide on where to start sequence. This is feature-based modeling, right? This is feature-based. This is why you need that one. And then create sketches and fully constrain them to meet the design intentions. If you are not going to fully constrain them, you can't predict its behavior when you change dimensions and other things. In order to make sure that it will retain the way I want. Now you all can think. You have a very good analytical skills as well. Now, I was observing maybe a few months back two persons cutting a huge coconut tree and everything in my garden actually. It's a restricted area. There are nearby houses as well. But it didn't take like maybe half an hour. They finished the work. Right? Only two persons. One is to control the rope and another one is cutting the tree on top by piece. Nothing happens, no harm at all. I had even several other small plants and other things. Nothing happened. Right? This is fully constrained. When they create the cut and have the rope, they know exactly where it's going to fall. Fully constrained. If not, if it is unpredictable, I can imagine. How do they develop that one? Practice. That is the practice, nothing else. I mean, I myself can't do that. Knowing all these theories and scientific facts and other things, I still find it maybe not find it maybe impossible to do such a thing. Understand? So this is why you need to practice. And then choose the most appropriate tool to build up features. Just an example, a cylinder, extrude command, revolve command, sweep command and the luff command, the last two we're going to learn today. Which tool I'm going to take up? You should know the advantages of each and every technique. The features, sub-features available in each method. Or in what way I can control just the cylinder. If it is just a cylinder, then it's not feature-based modeling. Maybe in future you might change that one to a half of that one, a semi-cylindrical component, or maybe a tapered component, or maybe even something else as per your design changes request you to do so. So then you have to select the right tool. The reason is that in feature-based modeling, you can't delete whatever the things that you have added to your feature tree. Then what will happen? All the children will get affected. Sometimes they even disappear. Entire model collapses. That is one disadvantage in the feature-based modeling. You have the flexibility as well, and sometimes you find it difficult to control the flexibility. Right? Flexible, but you should know how to control it exactly. Most people find it difficult. We'll see what when we start learning the synchronous modeling and other things. And also edit, redefine and reorder features. Redefine. Sometimes you have defined some design intentions, your dimension schemes and other things. You find that it's not the most appropriate to do so. I should be able to go back and then redefine them. Sometimes you start sketching on a particular plane. Later you decide that, okay, that is not the ideal plane to decide. I should be able to go back and redefine the item. Change the order. A feature has been created before another feature. How can I change the order? What flexibility is available to me to do so? And how do I design to take advantage of that flexibility? Unknowingly, I can make your model very solid, like hard to change, very rigid. Knowing the flexibility of the model, you started using the software, but you have not taken actions to support that one. Understand? So this is what you should realize. It's a simple way. Say for example, water is the fluidity and other things. It takes whatever the shape of the container that you're going to put it in. But if you put everything into a refrigerator, convert it to an ice, then you don't have that flexibility. Right? So this is what you have to understand. Of any given part, not just the part that you practiced, maybe the parts that will come tomorrow, of any given part. It's very, very important. In ordered modeling, remember, you must think ahead. You have to think what will happen tomorrow, day after tomorrow, in 1 month's time. Understand the consequences of each action you take. I'm going to take the action today, but the consequences will appear tomorrow, day after tomorrow. That is what I should be aware of. Otherwise if you can, you need to be very concerned about your actions. I mean, think maybe even 10 times before do some actions, right? The consequences. Otherwise, the feature-based modeling will definitely be a failure. Not for simple parts, of course. Remember, you are not handling simple parts every day like this. You'll handle much more complicated things than 100 times, 200 times, even 1,000 times complicated than the things that you are doing today. So how do I still use the software comfortably? Right? So this is very, very important. So if I take this example, right, I put always these dimensions in millimeters because this example. I don't know whether you have done this or not. How many of you have practiced? Have you practiced already? Right. I don't want to waste time on creating polls and other things. Now, see whether understand this. First, you have to read and understand this. Otherwise, you find it difficult, right? Can you see the entire product and see whether the dimensions are all correct? Is there any something missing? Let's say, for example, there's a hole in the horizontal plane. The diameter is 18. And also you have another hole in a horizontal plane. Like the diameter is again 18, same diameter, but the axis is horizontal. Can anybody tell me the depth of the hole? It's not given. It's not given. So can you assume that one as a missing dimension? A missing dimension. And also you can see that the protrusion part, the horizontal cylindrical part with the hole, where the diameter is 26 and 18, the length of that part is also not given. Can we assume that one too? Can we assume the depth of the hole, and then can we assume the length of the protrusion part? The first one is obvious mostly. There can be mistakes, of course. That depends on person who is going to create this one. But anyway, if you receive a drawing like this and if you assume the hole to be passed through, there's nothing wrong in that one. There's nothing wrong in that one. Why? Because if it is a blind hole, where it's not going to pass through all the material available, then the depth has to be given. If the depth is not given or indicated, you can safely assume that it is going through. That is valid. That's a valid assumption. But how about the other part? There are possibilities. There could be a definite value for the depth or the thickness of the part, or it could maybe end up with the surface here, or it could end up with surface here as well. Now it is difficult. Now it is difficult. You cannot make that assumption. You cannot make that assumption unless you have some other guidelines from somewhere to ask for this one. This is something like missing information, right? Something like missing information. So this is the part, a 2D drawing. Now you can clearly see the missing dimensions are also there, and then your hidden details shows that the hole is passed through, right? So only dimension missing is that 15 millimeters, right? So what I'm trying to tell you is that if it is your product, you should make sure that everything important is given. Everything important is given. If you give the isometric view like this, what is on your left hand side, you may not be able to give all the dimensions. And if you choose the other one, the 2D drawings or orthographic projections, then sometimes you can and sometimes you can't. Why? Because there are more details, hidden details and other things. So that is why in engineering drawing we have, sectional views like the full section, half section, part section, removed section, revolved sections. There are different views. I mean the partial sections. There are many. And the detail views. Why? Because you need to make it a definite product, definite drawing. That is when it comes to engineering drawing. Right? So you will be producing some engineering drawing once you finish your modeling and the design work. So make sure that all these parts will meet the standards of the engineering drawing. Right? A kind of a learning thing. So let's see how we're going to model this part. So remember, as a practice, as a learning exercise, I can give like this: assume missing dimensions. But in reality, say at the end of your project, you can't use this sentence, right? Completely wrong. You can't do that. Assume missing dimensions. It has to be perfect. And also, there's some other thing also coming up. When you give drawings in the classes and other things for the sake of learning only, sometimes we give what? Not to scale. Not to scale. But you can't do this one in a real drawing. You can't put that one. You might be thinking that I can escape from that, but you can't do that. Okay, so please understand all these things. I'll discuss those things when it comes to the drawings and everything. So now you have the product. Now you have to start thinking. Where do I start? What are the major features? What are the minor features? Or the order of creating those features. In general, as a general guideline, remember you start with major features and then go into the minor features. How to identify major and minor features will also depend. Some people used to say a fillet. Fillet is a command in the software. It's a minor feature. No, don't have some kind of an understanding like this. Now, if you see this, the horizontal plane, there's a semicircular part with radius 17, and you can construct that feature with the fillet command. But that is not a minor feature. Right? I'll come to that point little later. I have a good example for that one. So this is what we should usually do. Study the part and define the design intentions. Now this is not my product or your product or whatever it is. It's been captured from one of the drawing books. I mean, we have been using this one for a long period, especially for the 2D drawing class. Maybe you have some experience in, creating the 2D drawings of this thing. But anyway, at least, before I convert this one into a feature-based model, then I should have something. You can think of the symmetry, right? You can think of the thickness. For example, look at the 8 millimeter thickness of the vertical portion. And there is a small one also that even goes vertically, the thickness is given. But how about the horizontal one? The thickness is not given, right? And looks the same. Now, can we assume that one as well? Can we assume that one as well? It depends on the application of this product and everything. Now, if I say the thickness is same, now you see there are two thickness values, 8 and 8. Can't I assume both or all three have the same thickness, so that I need to define only one dimension? A lot of questions will be there. There are two things. If this is just a drawing prepared without thinking of feature-based modeling and the intentions and other things, of course you can do that. But if this drawing has been prepared thinking of the feature-based modeling and all other intentions and other things, then you can't. Why? Because there are 8 dimensions, means I can control them independently. I can make one 10 millimeters, other one leave it at 8 millimeters. Now in that case, how should I decide the thickness of the horizontal plane? Either the first 8 millimeters or the second 8 millimeters. Now those are the questions that you need to find out answers for by yourself. Right? Maybe initially, because you are not going to do some like a useful work with this particular part, for the sake of practicing the tools and other things, of course you can do that. But my advice is to try all these different options, then you will realize what are the differences as well. Right? And then after identifying the base features and everything, I decided it to be like this. Right? The highlighted one. that is the base feature sketch, and then I'm going to extrude that one into that direction. The depth is given, everything else is known, or someone else can decide only the vertical, the big one is as my base feature. I think I gave you a good example in the other week as well. Now, if I can model the features at once, why should I separate? Separate means I am expecting some flexibility. So for example, I need to keep this big L-shaped thing and then remove the middle one. For some reason, in future, there's a chance that I'm going to remove that one as well. Then I need to separate them. That is the flexibility. If I don't need that, why should I add some unwanted, unnecessary flexibility to the model? That you should not do. Right? So this is how you're going to do this, for example. Right? So if I go to the sketch of this one, again I say the assume is in dimension for the sake of learning. This is where we have it. Now I'm going to introduce something additional today, the highlighted in blue color. Right? Now once you finish this sketch, right? Once you finish this sketch, first you have to identify whether the dimension scheme is achieved or not. Confirm whether the sketch is fully defined or not. And also identify whether there's any missing or redundant dimension in the sketch. This 40 millimeters is a redundant dimension. Or in other ways, you can derive that one from the existing dimensions. You should not give that one. If that is given, then one of the other dimensions should go. One of the other dimensions should go. But you look at the color, I didn't change. Of course, you can configure the solid edge to display it in different colors. But it says this, what you call this 40 is become a reference dimension or a driven dimension. I cannot change this 40. I cannot use that one as a driving dimension to change the base length of the feature. I cannot. But when I change one of the other three dimensions, horizontal dimensions, 40 will automatically be updated. It's a reference dimension. Sometimes I put reference dimensions because I want to know the overall size of the product. Without giving that, why do I give the other three dimensions? Because those are called the functional dimensions. Functional dimensions. I need to control the individual dimensions as it is, but not the 40. But 40 is important for you to know the big picture of this one, the overall size of the product. So then I put that one as reference dimensions. Sometimes you manufacture the product to the given dimensions and you can use that one as a 40 as a checklist for check dimension. Check whether you have achieved this one or not. Why? Because the 16, 8, and other 16 with tolerances finally can become 40, 0.1, 0.2, 0.3 or something like this. Right? So with tolerances it's going to be very useful. We call the reference dimensions. I'll show you that one, right? I'll show you that one as well. So let's have a small demonstration on that one, right? If you can, I'll switch to the solid or the edge screen. Hopefully you can see the screen. I will start a new part and then go to the standard and then go to the, I can maybe today use a different thing, metric and then the metric part. Try to open them and see. These are only, the templates, right? Your design approach and everything will still be the same. Maybe the dimension style might change. Material properties might change. That's the only thing that is happening, right? Otherwise, nothing. So, no harm. Anyway, you select this one. As usual, you get this, right? Your select tool and then the ordered modeling. These things in your solid edge software might appear in different locations. So that is what I want to show you as the customization part a little bit, right? Sometimes it appears in a collapse mode, right? When you move the mouse cursor over that tool, that's where you're going to apply it. And sometimes it appears on a different screen as well. very confusing sometimes, right? When you have multiple monitors, sometimes that can go into the other screen as well, right? So the system might not respond until you close that dialog box. Anyway, so which plane I'm going to select? Which plane I'm going to select? So you remember the part. Oh, this is accidentally I click on the I so I go back. Let me uh, until I escape and then start again. So where were we? We at this modeling of this, right? So start. Oh, what is that? Still, it is not the same thing. I didn't double click. Right. So this is where I have this thing, and then I will go into the solid edge screen. Which plane I should select? Remember your what you call the initial screen, right? Just like this. And if you see the product, you remember the orientation as well. In order to sketch this figure, which plane should I select? Front plane, right plane, or the top plane? So if you click here the home button, this is how it's going to appear, right? So your product should appear in the right orientation if you define that. So in that sense, you can see I need to select the front plane to sketch. Remember, there are two methods. One is to have external sketch, and then other one is to straight away start with the command, and then it will create an internal sketch. There's no purpose of having an internal sketch in this particular feature. I'm not going to reuse that. So then I'll start with this one, and then it's asking me to select the sketching plane. Now you see that select a sketch is not available because there are no sketches in the active part. So I need to select the coincident plane. I just click on that one. It will automatically give me the what do you call, yes, sketch orientation. Sketch orientation. Now you are using the line tool is active automatically. You can see over here. Right. So if you select the circle tool, so those things will change. Right. So be aware of that one. You can drag this one and then place it somewhere here as well. If you have enough space, then of course you can do that one as well. If you go back to the line command, it will show you the line command as well, length and other things. And I saw in a YouTube video, right? I don't know, maybe not maybe somewhere in Pakistan or Israel or somewhere they use, to type some values here, length of the line, say how much is that, 60, and then use to sketch that one. Remember, I told you this is not a drawing. You should not waste your time in doing that one, right? Because if you try to do so, I will, if enough time, I will show you that video as well. Right? So what you do is you just freely sketching. Today I will sketch. Maybe you can remove all these things. You know what you call the IntelliSketch and all these things, and then you can try to model these things, right? So maybe let's say now you can start like this. Remember, the first one should be to the approximate length, right? Otherwise your changes will be quite large. And then like this, and maybe like that. You see, just very ad hoc thing, or maybe like this. This is why we call this one. Don't do it like this. It's creating some relationships. No, right? Do you see even equals in? No, like this. How many of this? Maybe like this, and maybe like that, and maybe like this. No, okay. There is one thing that already created. You can see you can remove those things, right? And then even I can end up somewhere there. Okay, maybe even here. Right click and then finish. Right. So in the most simplest manner, you can even do like this. I'll go to the select tool. You see what these things are, right? Equal. You see, it's very difficult for me to concentrate on all these things when everything is active here, right? It's going to pick up. So that's why I should cancel them, or maybe I should be very careful about. So anyway, I selected that one, and then I delete that one. I can delete that. There's another equal sign. You can say it's going to be equal to this one, and then I say delete that one as well. Except those the coincident points, there's nothing now. So how do I convert this one? So I start with this, the end point, merge point. I click on this point, and then I click on the other point, right? And then I click on this point again, and then click on the middle point, right? You can try after that just by dragging. And then I want to make them vertical. Some of them are vertical. Instead of doing that one, I can click this point and then align with this one. So what does it mean? I have two options now. I can make this line vertical, or I can click on this point and click on this plane and then coincide with them. Is there any difference between the two methods? The first method, if I define the line as vertical, it is independent of the plane. Okay. If I use the second method, that coincide the points and the plane, means that point is always residing on the plane. So if I somehow or the other change the angle of the plane, the point will also follow, right? Maybe at this level it's not that critical, but maybe later it's going to be very critical. So that's why you should understand what you are doing, the consequences of your actions. You should know. For this point, not difficult, you can say vertical point or the horizontal ones. It will turn into the most closed one. Let's try. This is vertical. Horizontal, also the same tool. Horizontal and vertical. Can I tell the software, the Solid Edge, convert this line to a vertical line? Yes. You listen to me. Convert this one also to a vertical line. You listen to me. Right? And how about this? Okay, now, maybe I just go there. Let's say this one. Let's see what is happening here. Okay. This one, vertical. And this one, vertical. Don't click on the midpoint. This one, vertical. This one, horizontal. And this one, horizontal. Is it horizontal? The mark is not there. You can see now, right? So I click that one. Now the mark appears. This one also horizontal. How about this? Horizontal, vertical. Yes. I will undo the last step, right? And I'll go to the select tool. Right? Nothing is selected from snapping. So if I make this point like something like this, for example, can I change this? Like this. And I want to convert that line into a horizontal line. Shall we try? Horizontal line. Now, why? Because it is too close to the vertical line. So when you sketch, you need to be aware of that one as well, right? But anyway, these things you're going to learn after this. If the relationships are over, not yet, not yet, right? Now you see, the thickness of this part and that part are supposed to be the same. You can safely assume that condition, right? Now if I use this one, the relationship is for that one is collinear. So if I select the collinear option and click on this line and click on the other line, say what's going to happen? Like this. I'll undo this. And then I do the same action again. This time click on this and click on the other one. You see how it's going to respond? The reason why I ask you to be aware of what is happening in the screen, everywhere. You should be sensitive enough to those changes that are taking place quickly. Right? Is there an issue in that one? Of course, there's no issue, of course. But sometimes your model might get, like distorted heavily. Then you need some additional actions. Never mind of that one. And then I told you this is 8 millimeters, that is also 8 millimeters. Remember, there are two 8 millimeter values are there. I'm not going to take that one. So I'm going to decide my way, say equal sign. I'll say this one is equal to this one. Or maybe this one is equal to that one. You see what's going to happen. First one and the second one. Undo this and then equal sign again. The first one and the second one. Right? So if you are sensitive enough to capture all these things, you can do this one very quickly. And someone who is going to follow you behind you, right? Or even if when you are watching a YouTube video, you might find it extremely difficult because he's not going to tell you everything. Not enough time. Right? Now all the dimensions are done. All the dimensions are done. There are of course some nice tools also here, but I will not complicate your understanding at this moment, giving you all the options. Here you can see the relationship assistance and everything. For complicated sketches, we can use that one. Remember, I asked you not to complicate the sketch whenever possible. Right, now my second part is over. What? Sketching is the first part. Second part is the define the relationships. Now I'll go to my third part, which is the dimensions. Carefully follow the dimension scheme. Now, remember I told you there are two methods. One is I can click on the line and apply the dimension. Other thing is I can click on this line and click on that line and apply the dimension. Which one I'm going to choose? At this moment, both are correct. Assume that you have a kind of an idea, a very slight idea, that this line may not be vertical. For some reason, I'm going to make it slant a little bit. But that height, the vertical height, is the one that I'm interested in. Then select the horizontal line and the line on the bottom. Don't pick the length of the line. Because if you pick the length of the line, if you change the angle, the dimension will also follow. Right? You can practice those things. So for this moment, I assume that I'm not going to have that kind of a change. So I select this one and then apply the dimension. This is how much is that? 60. I put 60. Right. So maybe I will show you one more thing. Please remember this. Right. Now you see how the dimension appeared. This is called the line dimension. There are basically two dimension styles in engineering drawing. One is the line dimension. This is the unidirectional dimension. Sorry, right? It's not the line dimension. A line is the dimension text will be aligned with the dimension line. So if I want to switch to that method, then I go to the style here. You can see the styles. Right? You can configure a template. Right? You can configure a template so that you always get that one. Right? When you do your project, you have to do this. Otherwise, for each and every part, you have to do this modification. If not, what will happen? You see now when you submit your files, there will be many inconsistencies. One is one way, the other one is a different way. One is text size is some value, other one is a different value. One is in first angle projection, other one is in third angle projection. Likewise, you have inconsistencies. That is not allowed. That is not allowed. So I'm talking about the dimension. I select the dimension and select ISO millimeters. That's what I'm going to use. I can apply this if you want. Or else I can go and modify this. You see there are different values are there. Units. How do you find the units over here? Right? How many decimal places, sound off and other things are there. At second unit, say maybe not important at this time, go to the text. You see the text size is also there. It says 6.5 millimeter. I'll say something like 3 millimeters. Now on the screen, what do you mean by 3 millimeters? Because the screen is always like dynamic, you can zoom in and out if it is not clear. Right? And there is also one other way to increase and reduce the dimension text size. And then it says the orientation. This is always horizontal. Right? Now I say it is parallel, aligned. Right? And it says it's embed. Now I say it's above. The text should go above. This is also the same thing. I'll say here parallel and then say above. It's already above because I have selected over here. And some other things which will come to a later time. What did I change here? Change the dimension, text size, and the orientation of the text. Okay, you can say close. And then you see it is already applied. We won't want to apply it again, but it is already applied. Now it appears like this. And then I can continue. Maybe the same thing. Either the distance between these two vertical lines or this one. You try applying the change both. Remember, this is something like 8 millimeters change. And maybe I will continue to this one also and then see what's going to happen to the other one automatically changes. Can you see? Because I relate them with the equal sign. You can make all three equal, but I need to follow the dimension scheme given. Then I will follow this one. Remember, what you usually do is you apply this dimension there. But if you go to the dimension scheme, there's no such thing, right? There's no such thing. I will take you back to for a while. You see, 16 is given from here to here. That is what it is important, right? And then back here. So apply the dimension between this line and this line, and then say it is 16. And then this line, again, two options. One to pick this line, other one is to pick the other two line. I will assume this is the one. So that is also 16. There's one blue color line. Why? Because this height is not given. So I put this height, I'll take it out, and then this is also 16 according to this one. So it is fully constrained. Right? When you see everything is fully constrained like this, don't get satisfied. Sometimes during your practice stages, you can see that maybe at the end of this one, when I zoom in like this, there's a small piece of line just hanging around that. I can't see that. Why? Because it's too small. Right? Usually it happens. Then it becomes underdefined. In SolidWorks, you can see it very clearly, but even in Solid Edge, you can see that one, but not as a color. Because what is indicating is whatever the things that you have defined. Now it is fully done. Okay, I will continue to apply a dimension from here to here. Right? I hope you can see that from here to here. You see what has happened? 40. Right? So if I want to change some values here, 16 to maybe I'll say 18, right? I'll change this one to 18. Okay, you see the variables appeared when you, I'll say 20, something like this. Let's say what will happen to the 40. It became 44. Right? I'll undo this and try to change 40. You cannot. You see, only the formulas and things, I'll come to that one later. You can't change them. So that is why it is called reference dimension. Reference dimension. Otherwise it becomes over-defined. Right? In SolidWorks, it becomes over-defined, and you can convert that one to a reference dimension. But here it automatically comes. So I don't need that one anyway. I just want to show you that these things are also there in this thing. Fully defined, finish, and then I will close the sketch from here or there. I will close the sketch. You see now. Now your design intentions will apply. Why? It is symmetrical about that plane, the front plane. It is symmetrical. You see now it is on to one side. So I can select on this symmetric plane and say the value is 34. If you tab go enter key, you can do work. You see now it is done. And then say finish. And then if you want to have further extrusions, you can leave this dialog box open, otherwise you can cancel. And let's study this part. Okay, you see here. That is there. Sketch is internal. Right, sketch is in. Now when you turn it like this and then click on the home button, it will appear like this, as it is given. You can try to select different plane and see how it's going to appear. Fine. And then I go to the next part. What is the next part? Remember there is a semi-cylindrical part and the flat plane. What is the dimension of that one? 17. Right? 17. Let's go and create a sketch. Again, it is an extrude command. Now I need to select a plane. How many planes are possible? How many possibilities are there? Yes? I can select this plane, obviously. I can select this the top plane, or I can select the bottom face of this one. Three obvious selections are there. Or else, even I can select this plane, I can select even that plane. 5. Or else, I can select this plane and then define an offset. I can select this plane and define an offset. Right? Remember here, you have many options. So don't go into that complicated matters unless you need that one. This is where you have to identify your design intentions. That thickness of that part has to be the same as the existing part. If I want to have two different, what you call thickness values, then you have to define that one in a different way. So then I will select one of the first two options available. One is to click on this plane, or other one is to click on the bottom plane, but not on this plane. Why is that? Because that feature that I am going to create right now, the semi-cylindrical part, goes from the top surface of this one to the bottom surface. Suppose in future I decided in the first feature that horizontal line should be away from the horizontal plane, and then the second feature I have created from the top plane to the, or this the blue color plane that I already selected, highlighted, to the other plane. So it remains, the other part goes up. You can try. So it's not going to behave the way you want, right? So maybe I'll select this plane, that is the coincident plane. It comes automatically like this, right? So maybe I'll start arc option. You see here, tangent arc. I use the tangent arc option, right? I select this one and click on this endpoint. There are three possibilities. What are the three possibilities? One is the bottom end of this vertical line, top end of the vertical line, and the middle point of the vertical line if it is enabled. But you see, it's going to pick one endpoint. I have already selected the top plane, not the bottom plane. You can try selecting the bottom plane, what is going to pick. I'm going to pick and then continue. You see what's going to happen. I'm going to move my cursor perpendicular to the line like this and then turn. So it's going to create the tangent relationship automatically, right? The tangent relationship automatically. And then I will come and pick here the other endpoint. You see the endpoint is already marked. If you want, you can right click and see what other options are available. You see how many endpoints are there? Can you see now? It's going to select one of them. You can, by hovering the cursor, you can see what other options are available for you. But I'm going to select the most obvious one and then select this one. Hey, what happened? It has become black color, means what? Fully defined. It's going to be fully defined. How do I apply the radius? It is 17. Let's try. This one, the radius. Why is that in blue color? It's become a reference dimension. Now you see there's a little conflict between the 2D drawings and then your design intention. Actually, this 17 is not required. Why? Because it's a semicircular part. Is it given? No, it's not given. We assumed. Actually, it is safe enough to assume by looking at the picture. But who knows? The idea of giving this 17, maybe not to keep it as a semicircular part, maybe slightly different. In that case, you have to model it like that. Right? So how to do that? Maybe I'll undo this step. I'm just again taking you some more things, right? I just select, you say maybe say 3-point arc. You see the first point, and then you see the second point somewhere here, and then the third point somewhere here. Can you see? You can still make it like this, right? Or else I can make it like this, maybe something like this. Finish. Now it is blue color. Then I define the diameter, or rather radius, which is now driving dimension. I'll say 17 and then enter. Fully defined. Got it? Right, so if I want to use that 17 as a what do you call driving dimension, this is the way I should model. If I want to leave that one as a driven dimension, assume the tangency and the semi-cylindrical nature of the feature, then I have to do it in the other way around. So I'm giving you the possibilities, right? Because in future you might have to decide on your own for your own product. You see now it is done. I'm not going to draw this particular part. Say it is whether it is going to work or not. Right? Say finish. See whether it's going to work. You see it's asking whether onto this side or the other side. If you have this side, there's no material onto this side. But in this way, you can find an edge and then close the section. Can you see now? So that I don't want that additional line. In SolidWorks, sometimes you have to convert that edge and or maybe draw a line one over the other. Now you see, if I put this one as depth as what 8 millimeters, it's going to give me the result, right? This way, and then I will say finish and then say cancel. It's done. 8 millimeters. But what is the difference? So if I double click on this and then say change this 8 or maybe this 8, I'll make this one something like say 12. What will happen? You can see. Is that what you want? Is this what you want? I'll just turn off the planes for the time being. I don't think that this is what you want. So that I mean to change this one. So I right click here, edit definition. You can go to the edit definition. Here you can say the extend setup. You can say up to next, from to you can see through next. See whether it's going to work. Now, why? It's not going to get any material in that direction. Right? It's not going to get any material in that direction. So that is why sometimes, when you start modeling this one, you tend to use the other option if you can't find a solution. Why it is happening like this? Because in that direction, if you go and go down and down, you don't see any material. You're not going to meet any material, so that you can't do that one. So solid edge, the logic is different. So I'll say here from to extent. You can say through all. Let's try even through all. Still not there. Through next is not going to work. Finite extent, yes, but it's not what I want. Intention is not that one. I go to from to extent. Then I'll select from, you can say from extent to this surface, and then go to the to surface. I'll select on that one. You see now it is already there. Applied and then finish. Cancel this dialog box. Right. Now I can double click on this, and you see there are two protrusions in that. I'll change this one back to 8. Right? I'll put this one back to 8. See what's going to happen? Done. Okay. This is, there's still a lot to learn. Right? Anybody can model this. I'm obvious, sure, very 100% sure that all of you can model this one. But you will not identify those small points. Right? And rest is easy. Now, for example, I click on this one, or maybe it's a cut, for example. I select on this, and then remember it's a circle with diameter 18, same center, right? I come and then say center. You see, center point, right? You must select the center point and then say how much is the diameter is 18, I remember, right? It's something like 18. So I say 18, and it is fully defined. Right? Finish the sketch, and then you can go down. You can click like this, right? So for example, you can just click somewhere in the bottom, but that is not my intention. I can say now this time through all is going to work. I showed you the other day what will happen if you select these different options, right? Say through all, and fine. Let's try some changes. Remember, I used the dimension 17. Can I change it? Yes. Right. So I go back to this one, say cancel this. I'll say okay, home. Now if I say cancel this, so this is the one that I want to see. You see the 17. Can I make it something like say 20? Can or can't? What will happen to that feature? What will happen to the whole? It's possible. Is that what you want? Then if you model like in the previous case, it's not going to work. Right? So you decide on how to do this. Or maybe I want that semi-cylindrical part to behave like that, but the whole should remain at the same place. Different intentions. Still it is possible to model. Right? Still it is possible to model. Now you see undo is not available. Good example. You see here, oh I can't undo this. Undo is gone. I told you the other day, don't rely on the undo command. No. I know for sure, for almost all users, irrespective of the software, you rely mostly on undo. If you just count it, how many times that you use the undo command, you can see it may be the most, widely used command. Undo and the erase command. Right? Don't do that one. If you practice that one, it's going to be very unproductive. Right? So what can I do now? I can, of course, click here and then dynamic edit or edit profile or whatever it is. I can try dynamic edit. You see here 20. I want to make it what you call 17 back to this one. It's going to regain the shape. Right? Now if you go to undo command, how many undo options are available? Only one available. Still the same thing. Right? And then go to the other feature here. For that I will turn on the base reference planes. Again select extrude command. Right? And then click on this front plane. I get something like this. And then create a sketch, circle, somewhere here, and then select the sketch. Some people do like this. Don't do that. Because this outer circle will go only up to the first surface, the vertical surface that's going to be when you move towards the left hand side, but the whole, the inner circle goes through the product, pass through to the other end. Some people do it up to the first surface and then create additional hole there. And then some other people create the whole thing up to the last end. Both methods are not correct. Because you are creating material inside another one. You must try to avoid as much as possible. There are cases you can't avoid, but you have to avoid that one. So don't do the second sketch. Remember, I'll undo this. And then define the diameter, which is obvious dimension. Right? Which is that how much is that? Let me check. Which is 18, right? So I'll say which is 18. 18. Now it is still in blue color. Why is that? Because one more dimension is important, required. Right? How do I define that dimension? This way it is almost impossible. So I turn the model back like this. Zoom if you want. Then apply dimension from the center. Oh, it's not going to pick the center. Pick the circle, right? And then click on this horizontal edge. It's in the same plane. Click on that one. Define that dimension as 34. Is it fully defined? Black color, yes. And then I close the sketch. So this is the dimension which is not given, right? But in the 2D drawing, I saw that one as 15, so I define this one as 15, and then enter, click outside here, and then say finish. Okay? You see, once you finish your first part and other things, rest is easy. Sorry, rest is easy. Again, this is a cut, for example. Select on this plane. Make a concentric circle, or you can do the circle anywhere else and then you can make it concentric. Hold on to this outer edge, come here and then see center point is already picked. Select that one and then apply the dimension, which is, I think I made a mistake, right? Let me check. What is the diameter of the first one? I took that one as 18 also. I close this one. I go. So this has to be 26. In feature-based modeling, there's nothing to worry about that one. Right? So be aware of that one as well. Now again, I'm going to create a cut on this particular plane. You can start even from the back plane, right? But in the back plane, you may not be able to see this circle, the other one. Of course, if you enable the hidden lines, it is possible, right? But you go to the circle, hold on to this one, hover that, and then select this, and the diameter is now 18. Right? Now it's done. Close your sketch. Now this is the last feature. You can select through all, right? Don't select finite extent and then do it like this, right? Select through all or up to next. Click here and then finish. Cancel. So if you turn off the plane, this is your product. Is that clear? Though it is simple, you have to learn a lot of things. Right? You have to do experiment with this product and then see whether you can model this one in a different way. And after modeling, try to change dimension and see whether your design intentions can retain the shape of your object. Of course, within a certain limit. Everything is not possible. Flexibility is not indefinite sort of flexibility. Flexible within certain limits. Right? So if you try this one, then you will be able to do so. So that is the first or the additional part. How about this? We did something similar to this. Right? We did something similar to this. Identify major, minor features, select your base feature, and then start sketching the base feature, selecting a plane, and then continue to the other features as well. Now, if I see this one, is it a major feature or a minor feature? It's a fillet. It's a fillet. Now, my question is whether it is a major feature or a minor feature. I have two diagrams, right? Two diagrams. Anybody? I didn't have time to go through some polls, but anyway, start thinking, right? Start thinking now. I can create the first one, what is on the left hand side using the fillet command, and I can do the same thing for the right hand figure. I can use the fillet command. Okay, the thing that I want to mention is fillet command, fillet is not always a major or a minor feature. It's the value that will decide whether it is a major feature or a minor feature. And usually we used to say these things are casting curves. Casting curves usually less than 5 millimeters or 4 millimeters. And that comes automatically because of the casting process. You can't keep what you call sharp corners and other things. That comes automatically. But this is a kind of a diameter, which is, radius is 12 millimeters, which we keep purposely. So if you decide that one as a minor feature, then you will model this one at the end. Then, how about the 4 holes? Look at this picture. The 4 holes, the centers of the 4 holes are coinciding with the centers of the 4 rounded corners. That is how it is given, right? So if you create this the fillet as a minor feature, then also the 4 holes becomes minor feature, which is not. They are functional features, right? So you don't want to consider that one as a minor feature. But anyway, your option to draw this in one sketch, you can exclude that one. Start with a simple rectangle and then define 4 fillets, so one single fillet or whatever it is. Right? So let me go to this particular part. I hope I have already created that one today. See whether I can open it. Oh, where is it? Can someone see this particular part somewhere? Okay, here. Right? So let's see here. I have an external sketch like this, right? You see it is like that, and then the protrusion is like that, and then I have a round like this. I'll change this one. It says 25, right? I'll make this one say how much? I'll change this one to maybe 15. What will happen? Okay, right? Before that, I'll show you even the other end. There is a hole and also a fillet, right? You see, concentric to that one, to this one, and also a protrusion and a fillet. I'll change the colors so that you can see that one. Now I'll change the round again, 15 to 25 to 15. What will happen? Just enter and see, right? That's converted into a square shaped thing with 4 fillets. So there's a possibility that you can start with a rectangle and then finally convert it to a circular part. That may be what you need, right? But let's go and check the other side. Nothing has failed, no indication that anything has failed or not, but go and see the other side. Can you imagine? You don't want to tell me. You can have your own way of visualizing thing. See the possibilities, right? Okay, let me see and see. Why? I wanted that one to stay in the middle. You see that? The references. Right? Remember, it was not only one single circle. The circle was comprised of 4 quarter circles, fillets. So when I sketch this circle for the whole, knowingly or unknowingly, I have selected only one fillet. So it's attached to that fillet. Now the position of the fillet is moving, so as the whole position is moving. Now imagine what will happen. Imagine what will happen now. You are concentrating on this side. Others are you can consider as minor features. You finish the product and then send it. And then the person who is going to manufacture this one will manufacture this one as well. Now this is what the product will look like. So this is not what I want. You understand this? Right? How important to keep the references and everything like this. So even here it is the same thing. Right? So I'm not going to take too deep into this one, but I want to show you the part above, right? The part above. Maybe I will use the same thing so that you can see this one over here, right? Forget about the other 2 features over here. Maybe I can just suppress, right, like this, and maybe I can maybe make it even smaller. I'll say something like 5. Now it looks like that. Maybe I remove the other fillet. Now you see there is a problem here, right? One says it is suppressed. This is. Other one, there's a problem. You see now if you the round error. Edge or vertex did not recompute. I mean you can't. Why? Because when you suppress the whole, The fillet was created by taking the edge of the hole as a reference. So it is missing. Now you can't recompute that, rebuild that one. Right? So you have to be sensitive of that one as well. Don't keep any of these things in your file except what you call the suppress features if it is required. Right? So that there's nothing on this side. Model still works. So I don't want to have even this one. Right? Not this fillet. How about the second round? I don't want even this one. I'll make it simple because what do I want to do? Suppress. So simple, right? Right. Then as usual, right? As usual, the depth of this one hole. What is the depth? It's not given. So then you have to assume it as going through, right? Going through. So let's go and do it like this. Now remember, I have no idea about the first dimension. Did I have any dimension for this one? No, right? So then I'll create a cut on this plane, select like that, right? And then start sketching on the top plane, snap to this, have a circle like this. I will leave it open so that I want to show you that it is also possible. And then remember it is a cut and it is passed through, right? You can go like this, through all it is selected, show the direction, that's all. And then finish. I'm going to use the cut command again and then say it is like this. It's going through. Fine. How about the other part now? That is this part. How do I do that? There are many possibilities are there, right? So the distance is given. So I'm going to select again, select on this sketching plane. It will come like this. Don't get confused of the orientation. I will create a rectangle with corner rectangles like this, which is slightly bigger. I don't mind how big it is, maybe like this. And then you can define the distance between these two and then finish and then create a cut up to maybe not through all, maybe say the finite extent, you can say maybe up to this level, finish and then done. Yes, yeah, it is achieved. It is achieved. I will close this sketch for a while. Okay, so it is achieved. What is the difference? What will happen here? Say I'll go to this particular thing, right? That is this one, and then go to edit profile thing, edit profile, because the dimension of that one is not defined. It's defined. This is 20, right? I'll say finish. I will make that one. It's a design requirement, right? I will make that one. Say for example, that is not 20. Where is that 20? Somewhere here. I'll make it something like 30, for example. What will happen? Wow, you see? You can't even imagine that it's going to happen like this. That is why I told you, don't model visually. If you get the picture on the screen, don't think that it is correct. You have not defined references properly. Understand? I will undo that step and then do the same cut on the other side with the proper method so that we can see both, right? I'm going to create another cut, sketch on this plane, fine, right? So I'm going to have only one line. Line tool is automatically selected, something like this, horizontal line, finish. Then I'm going to use this one, what you call the convert to edge, right? So here you have the convert to edge option, project to sketch, I'm sorry, right? Select this, click on this edge, done, and then click on this edge, done. You see there are two circles, right? If you want, you can go into the wireframe mode and then go to the trim option, trim this part. No, it's not created. It's not created. You see now? Let's go there again, right? So select this again. You see a single face. Now I select, say for example, edge or tangent face, single wireframe, right? I select this one. Now it is done. Earlier, I have selected the entire face. Select, then it is done. And then have a line, horizontal line, right? Horizontal line. Escape. Then you go to the trim option. Trim this portion. It's gone. trim these two parts, gone. Trim that portion, gone, and then trim that is gone. Right? You see, it is like this. It's coinciding with that one, but maybe we have some problems, right? Because when you trim, you see that the thing has gone. You can try by changing this one. I'll see whether it is possible to change. No, it remains, except this line, the position. Finish, and then close the sketch. I'll switch back to the shade mode, and then go into the other direction, and then create the cut. Right, and then finish. Two identical cuts. Right, again I go back and change the protrusion of the other one. So finish, and then the other one. Right, how much was that? 20. Right, I change that one to 30. What will happen? First one fails, second one remains. Identify the scope of your feature. Don't create hidden features. The first one is like a hidden feature. I don't know the extent of that feature, the boundary, I have no idea. Right? Don't create features like that, because it could have any shape. Or maybe you might be thinking that if I create it even bigger than that, your problem is solved. Still not, because it's a wrong approach. Who knows, your diameter can go up to that level. And this fails, maybe several other features fail subsequently. And then you are in further trouble. So your approach should be identify what you call the feature scope and define the relations accordingly. Right? I used the existing edges and then created the feature. Understand? So that is the speciality in the second example, or the third example. One thing is that fillet is not always a minor feature. Right? So you have to identify the feature scopes as well, and then there are references as well. Don't try to modify the given dimension scheme. Right? Don't try to modify the given dimension scheme just because you can't achieve it or you don't know how to get it like this. So this is, remember we did something similar to this the last week, as a one feature, as several features. So you decide where you want to have your define. My advice is for you to try out all these possibilities so that you engage with the activities, right? And then of course I gave you a kind of a simple product like this. Were you able to finish this? If you have at least given an attempt, maybe it is complete or even partially complete, you have my email address. Kindly email to me. Remember, your file name, you should include your index number, and this is I would say what? Okay, I'll say example 4. I would say this is example 4. Right? Your index number and then ex4. That is your file name. Right? Anybody who wants to get my feedback, you can send it to me. My personal email address, that is jmangala@gmail.com, or if you wish, even janak@uom.lk. Until I receive some of the files, I will not going to discuss this one. I am going to give you an opportunity to test your knowledge. Right? Okay. Any questions? Dr. Lihil, you have some questions in the chat box?
In my chat box, no questions, sir.
Okay. Oh, again I go to the end. I have created some links. I can't remember where the links are already because I'm clicking. Right, so where were we? We were somewhere there. Right, so we'll start. Right there. Define your own dimensions and design intentions. Right. So this is where I have created some links, that is it has gone to this place. Right. So today I will just leave it for you. So if no questions, then we'll go into the other part. We're going to learn some more modeling tools, right? And then maybe halfway through we'll take a small break. We have learned already how to use the extrude command, both protrusion command to add material, cut command to remove material, and then the revolve command, again both protrusion and the cut. Right? Of course, that would be sufficient mostly, but anyway, don't limit your knowledge. You go into the other areas as well. Right? So what is available the next time? These are the things, remember, I showed you the other day. So we learn how to create sweep commands, maybe simple ones. Again, because these options, the commands have a lot of options and a lot of variations are there. You might not be able to grab all these things at once. So I will do it little by little. Right? You don't want to learn all these things, but anyway, if you are interested, you can learn, because that will be very useful. Right? And the sweep command and the loft command, and also we have this thin wall command, and also there's something called the rib command, and also multi-body command, adding additional bodies. How do I do that? Right? So this is the sweep command. You see the variation here. If you take that red color one as a straight line, and this part A, the rectangular one with rounded corners as a circle, then if you sweep command, then you end up with the cylinder. You end up with the cylinder. But here you can see you are sweeping. You are sweeping, you know the sweeping process. You are sweeping that section A, we call the cross section, along a path called B. So the result is the one that is shown next to it. Single path and the single cross section. And if you go to the one on the right hand side, there are multiple sections and then multiple paths. The paths at this case, even in the previous case, is referred to as guide curves. Guide curves. You are guiding the generation of the solid volume. And you can see in the second one, to the right of the screen, you have three sections, and the three sections are not the same, they are different. So while sweeping, you can even change the cross section. So in between two sections, the software will manage to generate by interpolating the surfaces or the sections. And finally, you will end up with a smooth construction. Sometimes you can have straight variation, the smooth variation, all these things are additional options. You can define any number of sections, but you can define only up to 3 sections, I hope. Let's practice this one later and see. 3 guide curves. Any number of sections, but 3 guide curves. Right? Let's try it in the most simple manner. Right? So let's have a kind of a demo here. Right? I'm going to use the solid edge command again, or the tool command again. Where is solid edge? Solid edge. Okay. So I will close this part. I'm not going to save it, right? So here you can see the dialog box is in the other window. I'll drag it and close, and maybe even this part. Again, the dialog box is in the other window. I say no. Then I'll open a new one. File, say new. Again, you choose whatever that you want and then say OK. Right? Okay, it's in the ordered modeling. Right? Make sure you are in the ordered modeling. And then if you select here, you can say add button here. And then you select here. You can see the sweep command, the loft command, the helix. You can create a spring-like thing, and other things are not active. Why? Because you don't have enough references for them. Sweep command you can do, loft command you can do, helix command you can do. And then if you go to the next available command over here, thing wall, right, like shell command in other software. And then of course you have some other options available. You can say network, even you can say rib command you have. Right? Let's try all these things today. Now let's try a simple one for the sweep command. You see a dialog box open. Let's try to study these details later and try variations. And it says, because it's enabled, show this dialog box when the command begins every time, so you can change these things. Otherwise you can go to options. I'll say okay. So you go to options, you can access the same thing again. Right? Now you have many options here. You can see here you are first selecting the path setup. Read this one, the yellow color one, path setup. And there of course you have one that is already selected, sweep protrusion sketch setup. And you're going to select, create a sketch because you don't have already created sketches. And coincident plane. Now the rest is the same. Right? I mean all these options appear will almost be the same. And this is something additional, we'll try those things later. Coincident plane. Right? I'll select, this is the path curve. I'll select this one. Right? So it appears nicely like this. Maybe I can end up with again a straight line, and then I mean at the end you will end up with a cylinder. Now I will use a different tool right now. They are what you call a spline tool, curves. Right? I select this one. Right? So you can see there are many options here. I will give a different introduction to the what you call the splines and everything. So I'm going to create a smooth curve like this. Right? So maybe something like this. Right click and then you can finish. So spline curves are a continuous curvature curves. The smoothness maintains. Right? And at the beginning, say for example, I want to make this one vertical. So you can see by selecting this one, or you can enable this one, right? And then say I go to select command, select this. You can say some of the things are available. I can say show the curvature combs. I'll explain those things later, right? Polygons, all these things are available. Now I can drag from this point. It's going to be smooth. And I can drag from these points. They're going to be smooth. Right? The entire curve is going to change. Can you see? Continuous curvature. So I'm going to select this what do you call horizontal vertical option and click on this point and click on this point. Make sure that they are vertical. So your spline starts in the Y direction. I hope they said direction. And similarly here I can end up with the same thing. Again, the vertical horizontal tool is active. I select this point and also select this, what these are called control points. You see what happens? And if you want to adjust the shape further, I can select this and then drag this one. You see? I can make it very smooth if I want. Right? And then accept this. What I have done, I have created what you call the path. You see the path already here. And then I can finish that step. And then next is going to follow the cross section. So finish. And then cross section setup. Again, you see the sketch setup. Plane, normal to curve. Yes, it's an obvious choice because you are going to create a sweep command or the sweep protrusion. The curve is usually, what you call generated perpendicular to this curve. But I made this on vertical, then I could even select this plane. Otherwise, if you select the curve, it will automatically create a plane perpendicular to that one. But nothing to worry. I'll show these things later. Coincident plane, and then I select this one. No point of selecting other one because those planes you will not be able to take along this path. I select that one. So what do I want? Maybe I want a kind of an elliptical, say for example, sorry. I want to say like an elliptical thing, for example, elliptical center point. Say I select this one and go into that direction and then go into that direction. I leave it under define, right? So you see what is the shape is like, and then say finish. Now if everything is done, you can say, I can say finish, or else I can go and modify again. I can say finish and then say what you're going to get. You see? Alright, so I say finish and then say cancel. And then turn off the reference plane so that you can see this very clearly. Right? So if you go and modify the path or the cross section, it will update automatically. It will update automatically. And this cannot be modeled using the extrude command in solid edge. And you can see the smoothness also, right? The curve is very smooth because it's all analytical curves, right? For that point also I'll come later. That's also there. And you can do it further. If you want, you can add something. Maybe you can start creating extrude command here. And then you can start revolve command there. Or you can create a hole through this one. Add something maybe from sides, whatever it is. Right? So that is in the most simple manner to create a sweep command. Right. So I will show you some more options. I'll show you some more options. But before that, maybe we'll take a small break, I hope, because it's almost like 5:30 now. Right? Take a small break and then come back. Or in the meantime, if you have any questions to ask before stopping or even after the break, you can come back and then ask some questions. Right? So then shall we stop for a small break? Right. Okay, as usual, no response.
Janaka sir,
Yes.
there's a request that the material students have another lecture at 6 o'clock.
Okay.
Will you be able to finish by 6 or
Uh, yes, yes. Then I will not be able to go through all the things, but if
hmm,
it's okay, it doesn't matter
hmm.
because they
Maybe
are also important.
later maybe we share
Yeah, yeah,
the
yeah. So
video with
then
them.
without a break, shall we continue until 6 o'clock?
Will
Is
you
that
be
okay?
able to finish everything within 20 minutes, sir?
No, no, no. Because the other parts are still more. Now the thing is, you get more and more options.
Hmm,
I can just give a kind of a demo and then finish off my work, but I don't think that is going to help you.
hmm.
Right? So
So
there are
then, sir, maybe
it's only
we will have a break. No,
yeah,
we'll have a break,
yeah,
and the material students can leave, and later the later half of the session, like
mm,
after 6 o'clock, we
yeah.
share the video with them.
Okay,
Hmm,
okay, okay. So then we'll have a small break.
okay. So at what time we should come back?
In 10 minutes.
In 10 minutes. Okay.
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 Let me show you one more variation of the sweep command. Now what is this? During the break, I changed this one. You see, the bottom is like an elliptical shape, oval, and at the top, it's a circular shape. And then in between, you have a smooth shape following the path curve. Following the path curve. Didn't add anything else. Right? Let me do it again. I'll undo this. This is what you had. You can do it at the beginning, or you can even modify the existing one. Right? You know how to create from the beginning, whatever it is. Let's see. I'm going to right click on this protrusion and then go to edit definition. path setup, if you want to edit the path, you can do so. Now I am going to select the first section setup, right? You see there is one already there. If you want to edit this one, you can click here and then go to the edit button. Okay, we'll come to those details little later with more complicated things. I'm going to add one more thing. For example, here is the select sketching. I'm going to add one more section. The usual option comes. I'll this time select a different one. I'll select parallel plane, right? And then first click on this parallel to this one, which is our original scheme plane. And then I'll zoom into this corner and say this vertex point. You see, it's going to select the vertex point of the curve, right? So this curves, you call it as vertex point. Click here. Right? Now, if I show you the actual picture, you see it is like this. You're looking from the top of this one. So I'll go back to the sketching plane. You either press Control H or this. Then I'm going to create a circle where the center of the circle is going to coincide with this one. You see the again. We call this one the pierce point. I'll explain those things also as later. And then we do it like this. See whether the okay, maybe it's a bit small, doesn't matter. Now again check where the circle is. Right? Circle is at the end of the curve because the plane is over there, so the center is coincide with that. Then finish the sketch. Right? And then you say finish. And preview, you should have your part. You see, it's not that difficult. Right? And then say finish to get the curve up. Right? So if I show you some additional command out of the usual path, I'll choose this what you call the mirror option, the mirror tool. Right? Select features, steps or whatever it is. I'm going to select this particular feature. Right? And then accept. I'm going to select the plane either as this one or maybe as this one. Right? You can choose whatever the thing that you want. You're going to end up with something like this. Right? And then finish. Now you see some problems. That's why I wanted to take this one now. Maybe I'll select this till orientation. Look at this here. It goes like this upwards and also it goes like this as upwards. But what do I want? I want to have a continuous thing. If you take this one, this will also give you something similar to that. But when you design products and parts, you can't have such variations. How do I control this sweep command, the loft command, precisely the way I want? That is something to be discussed maybe in one of the future lectures. Right? Maybe it is still too early. But anyway, it is a requirement. I mean, don't get satisfied with that one, right? Because when you see this like this, you don't see that option. You don't see that variation. Right? We'll later see how we're going to even check the quality of the surface which is already generated. Okay, let's go into the other one. I'm not going to make you more complicated today. That is called the loft command. So similarly, you can create even cut commands, right? Same steps. Only thing you need to have material. Loft command, something similar to the sweep command. Today I will not go into the what you call with path guide curves, but straight away this one. In some of the software is identified as the blend command. Blend is mixing. Right? You need to have more than one cross section, and then the software will interpolate. For the sweep command, you must have a path curve. But here, if you're going to use only the cross sections, maybe you don't need. Right? Let's try, or maybe I can even leave it for the time being, because other tools are maybe more important. I'll come to this one if the time permits. Like for example, the thin wall command. Thin wall command. It's very useful for you, right? For example, if you go to this place again, maybe I'll start a new file. Right? I'll start a new file. and then select isometric or metric, doesn't matter. Let me create a very simple protrusion by selecting this one as sketching plane. Then I'll create what you call a center rectangle like this. I'll have some dimensions. You can even create dimensions automatically. Let me make it 125 and then maybe something like 80, this one. Fine. And then close, extrude up to a depth of maybe say 15, maybe even a bit more, 20. Right, so that is there, finish. Okay. Click and then finish and then cancel. So you have a box like thing. There are many options. I want to create a product made of thin sheet. Internally it is a shell, empty, but closed from all sides. Or else I want to open one side, and then create a product made of a certain thickness, maybe a sheet metal or maybe even slightly thicker than this, right? So how do I do that? If I see here, you can see the thin wall is already accessible. I click on here. It says common thickness. It's asking the common thickness. Remember, this was something like 120 and then 25 and 80. Right, 2 millimeter maybe not visible. Maybe I'll say something like 5 millimeters. You can tab if you want. Then you say open faces. Open faces means I want to remove some of the faces together with the thin wall command. Or I can just preview and see. Then it will be all internal. Then I have a section to see what is inside. Let's see this one first. Chain. Right? Or else we can see the other option as well. Feature, single, I'll say chain. I'll select this edge. You see it's going to select right round. Select that one. And then accept that one. If you have some more, you can even select that one. And say preview. You see this is the feature like. And then say finish. Right, so let me turn off the planes. So it doesn't matter what the thing is like this. Right? Or else maybe I'll do some modifications here. Say 5 millimeters. What was the thickness also like 5 millimeters, right? So then I apply 4 fillets here. Maybe I'll say something like 15. I'll see what's going to happen. Right, so I'll select this plane and also select that one. And then accept and then preview and then finish. You see what this point is? Thickness is almost negligible. It's a very weak point over there. It's a very weak point there. Right? The design is not acceptable like this. The design is not acceptable like this. How do I modify this? How do I modify this? Do I need to undo this one, go back and then create this again? Or do I need to create an internal fillet? There are various options. You can try out all these options, see what is more relevant. Now what I'm going to do is, I'm going to take this thin wall command or the feature and then drag it and then place it after the round command. See whether it is possible. Right, after the round command. Maybe I'll try the other way around. You see what happened? It's automatically corrected. Now it is independent. Now you can change the thickness. Everything will be automatically adjusted. In order to overcome that, if we apply a fillet internally, then 2 different fillets. You're going to have 2 different fillets. You got it now? Right? So that is what we call the shell command. Right? Maybe I'll undo the last 2 steps. Shell is also not there. Right? So maybe I will apply the shell command again or the thin wall command again. Common thickness, leave it as 5 millimeters and then say open faces. I'm going to select, for example, this plane as well as maybe this plane. Maybe I will select this plane. 2 sides I have selected. right? And then accept and then preview, you can see what's going to happen. So your product or your feature will be open from two sides, right? So that way you can have very nicely control the thickness of the product, right? So let me undo these steps because I want to show it from the beginning. What is this one, right? So I will this something for X. Maybe I need to start the solid edge again. Just yeah, give me a few seconds. And in the meantime, I will show you the other option, which is the rib command. Ribs are to strengthen the thin walls, right? Ribs are to strengthen the thick walls. So that is our next target. Let me see whether it's already up. What is this? Okay. I'll create a new button again and then standard, maybe metric or ISO, right? So then I will create the same extrusion again, say the extrusion, and then like this.
ඉප්ප ආනේ කර දාන්න ජරාව දාන්න මේකට
Who is that? Okay, and then define the dimensions. Say this time it is 100, and then I'll make it something like 60, for example. Right? Okay, it's done, and then finish. You create the extrusion onto this side. I'll say something like again say 20, and then finish. Right? Finish, and then I'll have something else also. Maybe let's say somewhere here the base. I'll create some more extrusions. I'll say over here, and then I'll have a circular part, and then maybe say the diameter is something like 10 millimeters, and then it is again 10 millimeters away from this edge. I'll say that is also 10 millimeters. It's close anyway, this one and that one. So I'll make it also 10 millimeters. Fine. And you see it is like this. I will finish the sketch and then create extrude command here. I'll say something like again 15. I will just use the tab key to see that. And I'm going to show you one more option here. I'm going to use the treatment option over here. You see it is fine. You can go into that direction, click here, and then you can go to the treatment step. So I can create a draft one this way or the other way around. Maybe 10 did this, that's enough. Let's say preview and then say finish. Right. So you have a object like this, right? Then I'll use the mirror tool. So the feature, you select this feature and then say accept, and then select this plane, and then you will have it finish. And then again similarly you select this feature. We'll see what other options are available, right? And then say finish. So you have all these 4 legs. Say the one, maybe say for example this one, and then up, say the mirror tool, and then plane setup, which one I selected, maybe go to this one, okay, and then accept, then go to the coincident plane, so you see this one, and then finish. So you have this product, right? So let me turn off the lights. Now I want to use those 4 small pegs like thing as a support thing for a box like thing, right? I have created that one. Now if I apply the shell command, you know that the fillet is going to be a case over here. So I'm going to apply the fillet this time before I continue to the shell command or the thin wall command, right? Preview and then say finish. Done. Right? Then I go to the thin wall command. Say the thickness is still, I'll say 5 millimeters, right? Okay, and then go to the open face command. I'll select this face, right? It's already there. And then I'll say accept and then say preview. You see what happened here? Right? So if I go to the thickness setup and then make it something like 2 millimeters, you will see the effect. Can you see that? This is not what I want. I want a box. And to support the box, I need 4 legs like this. How do I avoid that one? Of course, you can fill this one again. It's not the way to do this one. So this is where we use what we call the multi-body option. Multi-body option, right? So maybe I'll cancel maybe up to this point. Maybe I'll say all these protrusions. I can say delete. Right? Thin wall remains, and because they're not related, you see, it is not related. If you want, you can start doing like this right now. Now you can add. So then the shell will not be there. Or else you can try to drag that one up, right? If you say undo this, like this. For example, if you take the protrusion or this one, the round command, you just select this one and drag this one all the way up to this, right? And also the thin wall command all the way up to this. That is one way to solve the problem. You see, I was able to delete that one. Why? Because there was no parent-child relationship between the thin wall and the 4 legs that I have created. But it's not always possible. This is not always possible. You can't do like this in almost all cases. So this is where we're going to use what you call the multi-bodies, adding bodies. You can say it's only one body. We call the design body. You can give a name for this one. Right? So if you add as different bodies, then you can apply those commands concentrating on selected set of bodies. That is called the multi-body modeling. Right? For you, sometimes may be useful when you want to design something so that some feature will not propagate into the other part. So then you have to first separate it, and then later you can combine them into one single solid body. Right? I will leave that option for the time being, but I show you, and I will show you the same product but with different set of operations, So that is what you call the thin wall command. And maybe I will turn on this again, right? Turn on this. Suppose this thickness is too small right now. Maybe it is not enough strength. I want to support that one, right? For the time being, I will add only one, but later you can see I can add even a series of what you call ribs right around. So what do? I select this command. Is it there already? You see over here? No, maybe here, because it's a thin wall thing. Now there's material, this is accessible. You select this one. Again, sketch setup, parallel plane. No, I want to have a coincident plane, right? And then select that. And also if you can have a parallel plane, and then you can mirror it, whatever it is, right? So you select that one. Now you don't see what is inside. I'll turn off on what you call the wireframe model. Now you see that one. All what you need to do is you draw a line, or maybe any shape. It's okay, any shape, right? But only one curve. So line tool is already selected. I snap to this internal surface, and then again the bottom surface. Snap to the bottom surface. Right click, finish, and then you can see how the line goes about. Only one line, right? Remember, only one. Maybe turn on this one. You can see very clearly. Oh, whatever. It's created already. Maybe no. Right? So then I'll finish this one. Right? I'll finish this one. Now you see it's going to create onto this side, create onto this side, or create onto this side. What is the thickness? Is 6 millimeters. Right? I can change this one. We say 10 millimeters or whatever it is. I just use the tab key, or maybe it's too much. Earlier one was maybe 0.6 millimeters. That is something like say, usually it should be less than the wall thickness, right? Usually it should be wall there. You see now it is this way. You can go up to that one. That's not applicable. This way also. This way you can't create. That way it is possible. Just click here and then finish and then cancel. You just had only one. So if you change this profile out of a file, it will automatically update. But why it is if you can have even a extruded part created. Simple extrude command will do that one here, but not always. Say I want to have one more thing. Say this is a coincident plane. Let me have a circular part here, cylindrical part. I hope I can create something not perfect. Create the circle again in the center and then have a circle like this, maybe slightly bigger. Now maybe I have a dimension also, you see over here. And then make it 35, finish. And then maybe extrude it, right? You can check all these things, say through next. You see, there's no material, right? There's no material. You can't say up to surface also not there. Maybe you can say from to extent, say from this extent to this one, fine, and then finish, cancel. I made it quite bigger because I wanted to show you. But if it is smaller and taller, then also you need some supports. If I create like in the previous one, the extrude command, here first case it is okay, but here it is not. Why? Because this surface is a curved surface. You will see that two edges it's already open, and you will have what you call zero thickness feature created. Because there is no contact, only a tangent point over here. So this is where these ribs are applicable. Let's see now. I'm going to create again a rib over here, right? Parallel plane, no, coincident plane, select this plane. It goes like that and then get the wireframe. Sorry. Okay. Remember this is the cylindrical surface, this is the base. I'll again create a line over here and over there. Right? I click, finish the line command, finish the sketch. Maybe you go into the shading mode, you can see over here. And then thickness is still 1.4 millimeters. You can say you can create it onto this side. Maybe I'll make it, okay, we will do the change later. This way and then say finish. Let me turn off the planes and zoom into this area first. You see this is straight. If you want you can even apply fillet. How about this? If you increase the thickness, you will be able to see that. It is slightly curved, right? Let's try to change the thickness. So I cancel this. I'll click here. You can say dynamic edit if you want, and you can see this thickness over here, which is 1.5. I'll make it something like maybe 5 millimeters. Is it going to work? Yeah. Right. Select this. You see this curved edge? It's going to follow the surface. There are no gaps here. No gaps here. How do I prove that there are no gaps? Use the fillet command, right, or the round command, and make it say small, say 1 millimeter, and then select this edge. You see, you can apply a fillet command over here. If there's a gap, you will not be able to apply a fillet like this. It goes into the other direction. You can try. So this is where the ribs are very useful. This is where the ribs are very useful. Right. So preview and then say finish. This is how it is been done. All what you need to do is you need to have a body to cover from all other detection except the open side. Open side you cover with one sketch. One sketch. Could be a line, could be a part of the arc, or could be a curve, right? Or could be several lines, but it has to be one sketch. And then SolidWorks or the Solid Edge will create a feature in that detection, right? These fillets and other things are minor features, and you can add those things later. You can see when this is going in that detection. Now this will tell you, sometimes you find it extremely difficult to identify places like this in engineering drawing. When you produce the 2D drawings, you see how it goes exactly. You see now, there are 2 steps here, and maybe later I should be able to even explain all these things, how the curve is generated on the manual drawing board as well. 2 steps, one is here, other one is here. One part is straight because the 2 diameters or radius are same, right? That is the rib command. And then we have learned even about the, what do you call, the thing part, thing wall part, right? And the ribs command. So let me take you to the presentation again. Some more question for you. Consider the following parts. 2 almost identical parts, right? Can we follow the same modeling strategy to model both parts? Of course, it depends on your design intention as well, right? And are the base features are the same? Can I start with maybe the same base feature for the first one as well as the second one? And can we have similar parent-child relations? It all depends, right? Now I have put a note there. The legacy engineering drawings may not give us the design intentions or the dimension schemes, because engineering drawing is completely different from that. Engineering drawing is actually at the end of the design process, when you complete your detailed design, and then someone will create these drawings on the drawing board, manual drafting. But right now we are not going to do that way. We're going to do it in the other way around. We're going to create the 3D model, do all these tests and finalize everything, and then generate, not draw again anymore, generate the 2D drawings. So drawings are generated. And then the dimensions, if you wish, you can apply your own dimension scheme for the 2D drawing to satisfy the engineering drawing requirements. Or else you can use the existing dimension which is already used during your modeling stage. So those dimensions become what you call driving dimensions, not driven dimensions. So if you have your own dimension supplied to the 2D drawing, right, so then it will not, though they will not reflect your design intentions, right? So that also you have to very closely, monitor, study, and then understand how do I create those things, because it could be a long process. Several members would do the same project, and if there are inconsistencies, then conflicts will start. You will never be able to complete one. You should have a common understanding of how you're going to use these things. You model with certain intention, and you applied certain dimension schemes as well, and that should go into the other levels. Say for example the manufacturing level. That is also a very, very important thing. Otherwise it's going to be very difficult. Very difficult. I have the product over here. I think the both products are there. I will just discuss and then let you try first. The first one, you can see one on the top with the colorful thing. You can see at the bottom there are 4 black color parts, right? 4 black color parts. It's something like a stool, like thing standing, or maybe a kind of a device where you can maybe sit on that. So the 4 legs are important. The 4 legs are important. I would say the 4 legs are the jointly they act as the base feature, right? And the shape above that will depend on that. this 4 legs. You can start with that. And then for the second one, what you see on the right hand side, bottom you can see something almost similar except those two black color straight portions. And the main body, the big body part is almost the same. And there you can see a small protrusion, slightly smaller than the outside body. That would indicate that this part should go and fit onto something. First one is kind of maybe a furniture part. Second one could be a machine part. Right? You can still modify further. You can add more things and then make it completely a mechanical part, and then the other one you can add some more features and make it completely a furniture like thing. Now in the second case, what is more important is the top part. Why? Because it should go and fit on something which is already existing, or maybe that design is going to handled by a different team. But anyway, they are given priority, so I need to wait until they finish and then get the shape, size or the dimensions, and then start making my part. So in that case, I can't start from the bottom. I can't consider the legs as such base features. You can't consider. You have to start from the beginning. Part looks the same. Both parts looks the same, and steps are also the same, except the first top part, and then the additional fillet on the other part. But you see, your design intentions are different. That also you have to understand very carefully. Right? In the first part, you can see you can start with defining the diameters of the 4 legs, but in this case you can't do that because those things come at the end. So how do I do that? Try to model these things. Okay, one, starting with these black color ones, you decide to have 4 or 3 or 2 or 1. I will give you some comments after that. Right? And starting from this, and then you go upwards. That is first model. Second model that we should try is you start from this part, because the top shape, the dimensions are imported from a different team. I don't have the flexibility to modify this. So start with that, then I create the other part. Right? Let's try. Okay, first with this one, and then second you start from the top like this. Right? And if you can email that one also, so that I can see your variation, and very importantly I can see your what you call the modeling mistakes that you are doing. Right? It is time consuming for me, but anyway I will get some support from our team, right, to go through all your models. Any questions in the bin? No questions? Okay, let me continue the important part. But anyway, until you practice and understand well about the ordered modeling, right, don't try to study this part. Right? If you can, I don't mind. Right? But this is you can't say this is new. Right? I think started in 2003 or 2005 somewhere. Right? For us it is new. For us it is new. Right? The industry is already using that one. Right? Industry is already using this one. And today I found one software. I can even tell you the name of this person, who is a book writer, an author, who wrote many books about SolidWorks. His name is Matt Lombard. You can search Matt Lombard. There are many books written by him for SolidWorks. Now he is in Siemens doing synchronous modeling. So he realized the changes, advantages and everything. There's a nice video, you can listen to that one. Right? Not to compare the software and then select one or the other, but to see what changes have been taking place, because there's a lot of experience behind both the software, because he has written many books. So that means definitely he should have So from a person like this, we're going to listen how to compare the different software like this. Anyway, so start like this. Before we go to the synchronous, we go into the direct editing. In SolidWorks, we have direct editing. In AutoCAD, we have direct editing, right? Direct editing, not going through maybe the features. One time when you start the feature-based modeling, you realize that is the tool, right? You see a lot of advantages and everything. But with time, they realize there are many deficiencies as well. Because when you put that one into practice, you realize that there are many things. When it starts failing or whatever it is. Same way, even the synchronous modeling and other things, you might find some deficiencies in the future. Why? Because your needs are different. Your needs are every day is updating. But before I go into this synchronous modeling, the intermediate one is the direct editing. Direct editing, right? So direct editing commands in Solid Edge allow you to modify models imported from other applications. That is the important part here. When you import a part from other software, usually it's in a neutral format we call Parasolid, IGS, STL, or whatever the form that you have, VRML. I mean, all these formats are we call the neutral format. So you convert, so for example, it's an Autodesk Inventor product. You convert from Autodesk Inventor to a Parasolid file. And then the Parasolid file you're going to import into Solid Edge. We have what you call double conversion. The data loss may be higher. Of course, for simple analytical shapes, hardly anything is going to be lost. But anyway, for complex shapes, definitely there will be many losses. But today, most products are, you see, these are, we call the organic shapes, aesthetic shapes are there. So that is why it is more difficult. But anyway, you can import. You can import and then work from that point onwards. But you can't access the history. Even though it is a history-based model, feature-based model, you can't access the history because it's going to convert into an imported body, a single body. And with that, maybe I want to change something, not maybe like huge changes, but say I want to change the diameter of a fillet, or the radius of a fillet. Or there are 4 fillets with equal radii, then I want to change one of them, be slightly bigger. Even in feature-based modeling, you can see sometimes it is difficult, right? Because you have created all 4 fillets as one unit. Then you have to suppress one and then create another one. So this is what we call the direct modeling. Let's direct editing. Let me show you. Right. So maybe I will start a new file again very soon. Right. So yes, new file, and then this. So metric mode, metric part, and it's done. I will first show you within Solid Edge itself, right? And then maybe I'll create extrude command or extrude part, right? And then I go and select this, have it like this, and I can apply dimensions and then finish. So I'll say this is 125 and then maybe something like 80 for this one, okay? And then finish your sketch. I'll use this particular tool here, and then maybe the thickness is something like, I'll say 15, and then enter. You can say it's upward direction. You can finish and then cancel, right? Okay, let me turn off the plane so that your view will be much clearer, and also the base so that you don't want to see, it's already. Then I'm going to apply what you call 4 rounds, right? Say one which we say something like 15, and then there will be 4 rounds. One feature, okay? And then one up. Okay, luckily it's not selected, and then select like this, and then accept, preview, finish, and then cancel. You see there are 2 features, right? So if I want to change the diameter or the radius rather of one of these fillets, I can't do that one because all are embedded into one single feature. Or else I want to have only three fillets. I want to have only three fillets, right? And then one should go. Again, then I have to go and modify this. Because you are inside Solid Edge, you can access the features, you can access the history, you can do the modifications comfortably, right? So maybe I will export this one. Maybe I'll save this file first. I'll say this is what do you call this? Direct editing. Direct editing. I'll say _1. Right? And I will export this one, save as, you see, save model as, save copy as, save as translated model, right? And then you can choose different formats here. You can see there are many different formats, right? You can even extrude into, you see, step file, all these things. I will going to select the Parasolid format. You see the extension is either x_b or x_t. One is binary, other one is text. Right, it has selected text file, doesn't matter. I'm going to, you see the name is part4 or the DE_1. Right, so I'll save this. But this one is still part1, right? Now what do I do? Here you have your direct editing tools, right? Delete faces, or else if you click here, you can see you can access many other, right? And even move faces, you can access many other, right? So what do I want? So for example, delete, I want to remove one of the fillets, right? Assume that you are in Sun, or else maybe I can open the other one and then show you, right? So for example, delete face, select these faces, okay? Single face, or you can select multiple. I'm going to select this face. Now this is where the topology will come. Topology is how these surfaces, edges and everything are connected with one another. Right? By doing so, you may not be able to break the topology. Then the structure will not be there. Right? You should be able to, now when you delete this one, there will be a gap created. The gap should be able to finish, right? Say accept and see whether it is possible. Can you see? Excuse me. Right? Now what happened is your 4 rounds are already there. I'll say finish. Right? But it has created additional feature. If you suppress this, the other one will pop up. You're not really removing that one. You're adding another feature, right? Called delete face feature. Now if you want to add maybe a fillet with different radius, maybe say 25, and then say finish, and then select this one. So now you have a bigger fillet radius, right? And then finish. That is this one. One of the things. Maybe I'll create one more extrusion over here, or maybe a cut over here. Say for example, cut. I'm going to create a hole somewhere here, right? The coincident plane. I'll just maybe locate in an arbitrary place, or you can even make it fixed location. I only leave it under define. You can make it if you want through all. Maybe if you want, you can just make it like a fixed extent. Okay, like this. I'll do it like this. Finish. And then do it like this. You see now it is already there. Right? Now if I want, you can go there and then see what options are available. You can say delete face. Regions you can delete. You can delete holes, for example. I don't know whether it will recognize as a hole. Or maybe you can delete fillets as well. There are many options. I'll choose this option first. Then I'll select this one and that one. And then accept. Say finish. That is gone. It's not gone actually, it's there. But to cover up that one, you have created another feature. I'll delete the last option, last feature created. so that I can get back to the previous one. Maybe I'll try the move faces, for example. Here you have many things. Move faces, rotate faces, and many things are there. Right? Select this. And then select the faces that you want to move. Maybe you see it's selected both. And then accept. How do I want to do that? Right? So it's the plane setup. Means I want to move that one in this same plane. Right? Right? So the plane setup and then say accept. So if I maybe cancel this, something wrong. Right? Okay, go to again the move face command. First select the face and then also this one, right? And then accept. It's going to select the movement step and then maybe I'll say maybe along this line or maybe say along this line. That may be too much. Okay, it doesn't matter. I'll select, for example, along this line. Or you can have maybe a sketch created separately and then it's asking from point to point, right? I'll click on this. I'll say endpoint, right? So for example, endpoint of this line. You see, endpoint is selected. And what is the 2 point? Again, I'll select this. And then maybe I'll say center point, or maybe I'll select the endpoint, the same thing again. Maybe I'll select, you see now it is moving. I'll select, for example, this endpoint. So it's going out. It's going out. Maybe I'll select the midpoint, for example. Midpoint of this. Can I select the midpoint? There should be a midpoint as well. Did I select the yes. I should be able to access the midpoint. Because it's still remembered in the previous system. If I just try, let me see whether it is going to work. Yeah. Even though it is not exact, so I can move the entire thing. Otherwise, it could have been very difficult, right? So now, if I go back to this one, now I will export this one again. Did I close? Yes, right? If I export this one again, say for example, save as, right? So translated. I'll choose the same option and maybe this is, I will replace this file, save, yes. Let me close this file. This is the solid edge file which you have, say, features and everything, and then I'm going to open that file. What is the format? Remember, it's a Parasolid format. You select from here, where is the Parasolid format? Maybe somewhere here, okay. You see now there are 2 files. I'll select the one that I created last. So it's going to insert that one into a template that you're going to select because it's an imported part. Now you see it is there. I'll turn off the planes. Now you see part is there with a different, slightly different color. But look at the what do you call this? History is not there. History is not there. How do I modify this? Earlier it was possible. And you can see even the shape is something, it's not very shiny also, but there are differences anyway. Now in this case, how do I modify? It's almost impossible. There's nothing. Then I go there, I can say move face, or else I can say start with the delete face command. I want to make all these things equal. There are different tools as well, right? And then I can go and then select delete and then accept and then finish. And then I can apply a different fillet over here. Maybe I'll say something like 15, same as the previous preview, finish. Remember, this is an imported part. You see that has been created again, right? And then I want to move this one. So I'm not going to show you all these options because it's time limited. And then I'm going to select, say for example, this one and then also that one. If you select only the cylindrical part, feature will not be created because you are moving partially, right? And then say accept. So I'll select the same thing again here. That is the along edge. You can see there are other options as well along the edge. I'll select along edge, right, and then select this one. It's up to you to choose. Say the key points. I'll start with maybe say endpoint. So you can pick the endpoint. You see its endpoint is accessible. Now let's try to see the midpoint straight away at once. If the midpoint is not accessible, you see it's there, right? Pick here and then finish. You don't have features, but you can modify this. This is what we call direct editing. Right? Or else I can now add some features onto this, right? You can continue your modeling from this point onwards. That is also possible. But only thing is, the history of the previous part is not accessible. Right? Finish. And then create extruded part. Right? Like this, you can create like this. And then finish. Then you can combine this as well. You can apply fillet over here, where I'll say something like, say 5 millimeters. You can apply. You can combine with the existing parasolid part. You can see the color is different, but anyway it's possible. Only thing, the first part I can't modify. Now let's try to move this part. Move face, cylindrical part. I'll select this part and also this part. I'm not going to select the fillet, right? And then accept. Then along the edge, maybe I'll select this edge. Similarly, I'll say the key points. Right? I'll start with say the endpoint of this, and then I'll choose the midpoint, because if I select the other endpoint, it will go out of the protrusion part. Where is the midpoint? Midpoint should be somewhere here. Okay, click here and then finish and then cancel. You see now? If not, you can imagine the hassle that you're going to face in order to move these parts. So likewise, there are many options here. You can say move face, even copy face, offset face is also possible, even rotate face, right? See how you're going to rotate this face, right? We'll see now. I'm going to rotate this face. Right? Select maybe this one and also this one, because otherwise what we call the topology will be upset, right? And then say finish. It's going to select by geometry or by points. By geometry, I'll say I want to rotate this one about x-axis. You know where the x-axis is, you see? Now you see over here. I'll make a small change. Otherwise, you can say even a big change is possible. But then the topology will be broken. Maybe something like this. I just click over here and then finish and then cancel. Okay? This is what you call the direct editing. But anyway, every time you create a move, then a feature will be created. You see, feature will be created. Why it is not failing? Because behind the scene, your original references and everything remains. Right? You can suppress, unsuppress features and then do all these things. You can say even there are many other things, right? Many other things. This is rotate face, move face. Right? If you can't imagine how you're going to model kind of a complex thing like this, you make it simple, and then later you're going to convert it into a complicated model like this. But anyway, remember that flexibility sometimes disappears, right? Because you're going to add many other features which are not, I would say, a kind of a feature base. It's not what you call sketch driven. They're not sketch driven. And if I want to change the angle, because I just did it arbitrary angle, you can try. These are the things that you should try. For example, you see here, edit feature. You see, edit profile. All these things are available. If I try this one, you see this is the axis setup. Now, maybe I lost it already, right? So maybe cancel it. You can try the other way around also. Maybe you can try the other one. Say maybe direct edit. you can have angle. Yes, you have the angle. You should know all these things. If I want maybe exactly say something like where is the angle from the top, maybe I'll say 30 degrees. Wait. These are what you call the variables. Right? I'll say 30 degrees. So you can have even fixed angle like that. And if you want to move the whole thing, that is also possible. That is also possible. And if you want to rotate this one to a maybe to a different angle, maybe you're looking from this, maybe around this axis, that is also possible. This is what you call the direct editing. So after feature-based modeling, and they realized that when you want to transfer between different, the software tools, you can't access the history. Sometimes it's hidden. Sometimes not at all that you're going to access that one. But still you want to modify. Say for example, a customer is giving you a product for you to do some work, maybe manufacture, machine it, or whatever it is. And the customer has done some outsourcing work, maybe outside company, and he has got the 3D model from different company. And what they have given is a Parasolid model, or maybe an IGS model, which is a neutral format. Now they can't go and request it again. Then they might say, no, it is not our policy to give you the original file, or else maybe they'll say, maybe in that case, your charge will be even higher. Right? Even we do like this. If you do some models for an outside persons, the first thing that we would give is the neutral format. Right? And then they can do whatever it is. Now anyway, you're at the other end right now. Then you realize there are something that need to be modified. There are something that need to be modified. But cannot do so because you don't have the features. If you have no idea how to handle this one, then you request from the customer, sorry, I can't do that. I can't access your thing yet. Please go and change your part with the original modeler or developer. So that is a costly matter for him. Maybe the customer will go back and then discuss. You realize that it is going to be very expensive, and then on return he might visit some other place. That place, there's a knowledgeable person. You would say, okay, give us, no problem. You give us, there's no problem. And then he will do this kind of a direct editing and then do the necessary modifications. So what will happen to you after that? What will happen to you after that? Your client will spread the gossip, right? That this place, they don't know. But the customer is also unaware of all these things, but he will, exaggerate all these things, even to cover up his, poor knowledge of all these things. He will say, you can't do that. Or else, you try to model it again. You accept the job. Maybe your boss has accepted the job, and then you need to now convert it. Somehow or the other, you have to do it now because you already accepted. Advance is already paid. Maybe the only solution that you see is to model it again. Right? Now you model it again where you don't have the proper dimensions and everything. If it is a simple part like this, it's okay. But for a complicated part, you're going to make some mistake somewhere, and then when you manufacture the part, which could be a costly part, and then the customer will complain, no, you are not done our work properly. Part is not matching. Then you can argue, no, this is like this, we use your model and everything. Finally, a lot of arguments will take place, and then they realize that you have created the model again, which is not the same as what they have given. Right, so there are many scenarios I can give you like that. Right, so these pictures will explain you, how these things can be simply rotated like this, even this hole, and you can make these all 4 holes equal diameter. At once you decided, right? Maybe when you get your 3D model in the neutral file, it's not the same, right? So likewise, you can have it. So let me give you now a little bit more into the synchronous technology so that you can, if you want, practice a little bit. Right? But before that, you have to practice the what do you call this, history-based modeling, right? In direct modeling in solid edge. And in solid edge, it is possible to even combine hybrid modeling, direct modeling, even this, what do you call this, feature-based modeling, or the ordered modeling, and then the synchronous modeling. All these are possible. So in synchronous means several things happen simultaneously. In feature-based modeling, what we do is we access the features and then access to the sketch of that one, and then you're going to modify them. And then see the updates is going to propagate down the line. Many times it's going to be successful, but for complicated products, it's not going to be that successful. Right? You see the comment over here. Right? I'll show you something else also over there. Right? And it is, the synchronous modeling is the combination of direct editing and the feature-based modeling. The best of both is combined into one. Synchronous. You do everything at once. So there you are directly editing in the model. You are not going to consider what features are there, what they are, creation order, the parent-child relationships, nothing. You're going to directly access, we call the faces of the model. You see the face relations and other things. And then modify this. And in synchronous modeling, the sketch is used only to generate the volume. After that, there is no relationship. All these dimensions will be converted into what you call PMI dimensions. We call the product manufacturing information. I mean, the dimensions are directly applied onto the 3D model. Your sketch is useless after that. And something will be very useful, you have to practice and understand the steering wheel. The steering wheel is the one that controls everything. If you know how to control the steering wheel, then of course you can do the synchronous modeling well. But that takes time, of course. That takes time. You need to practice. You need to remember a lot of things. And not like in feature-based modeling, it will not create a history so that you can go back and modify like this. It's going to apply the changes directly on the model, like a clay model, for example. Right? And still you have the power of feature-based modeling as well as the direct editing. All is there. Now you see on the right hand side, right, some comments, survey results. 90% of the responders agree that the modeling is faster and more intuitive in synchronous modeling. 66%, maybe say 10 years back, I think this survey, 66% agree that working with imported models is easier. Imported model should be even more than that, because imported model almost impossible to modify in most of the other software. And you can say the last one agree that is easier to make changes even late in the design. Even late in the design. Feature-based modeling is okay if you practice, and if your mind is set to think like you are a feature-based modeler, maybe it is impossible for you to switch to the synchronous modeling. That's why I told you the other day, don't keep all these hard and fast things. Be flexible always. You should also flexible. Your thinking, your approach, everything. Be open-minded. Don't have any restrictions. If you have those things, then you find it extremely difficult, because back of your mind, subconsciously, you are looking for something else. You are looking for something else. Then only you will be able to master all these technologies. You see AutoCAD as AutoCAD, SolidWorks as SolidWorks, Solid Edge as Solid Edge, or even if you use Blender as Blender, maybe Photoshop as Photoshop, then you will be able to manage this one differently. Different tools, differently. Train your mind. It is possible. 100% not 200% possible. Right? So let's go and check. History-based modeling is a structured modeling process for the feature-based modeling. where history trees of features with parent-child relationships is created to define the model. And this requires preparing for design intent. Remember, we always discuss about this one, including dimensions, parameters, and relationships. You need to think ahead. What am I going to do next? What am I going to do next? So thinking that, then you need to set your values, parameters, techniques today. It was easier than the method that you had earlier, where there is no flexibility at all. If you want to modify something, you almost like started from the beginning. But here it is not like that. Right? So people developed that one. Wow, it was like a very, very, a great development over there. People started using that one. Many softwares were evolved with that one, became popular. But you say the 40% of the users said it is a top priority to be able to reuse existing designs. In the industry, you keep records of your design, and then as much as possible you reuse them because it's already done, verified, tested, manufactured, right? It's already there. So if you start from a thing like that, that's awesome. And also you can save your time, modeling time, your drafting time, everything you can. But finding and reusing existing design data was their third biggest challenge, especially with the feature-based modeling. Because maybe after some time, you forget all these things. How did I create this model? What features were there? Of course, you can create it nicely so that when you modify these things, it operates. But now what I'm trying to do is I'm trying to modify this and then reuse for different purpose. This is where I need to find out. So when you try to do so, several features fail and everything. This, and then you struggle and maybe you fed up with the operation and then you start from the beginning. And 99% of the CAD users said they need to work with imported CAD data. You see, 99% of the CAD users said imported data because you don't get the source. You don't get the source. Like sometimes today, if you create a document in Word, you would like to give it in Word format, or sorry, the PDF format. Or if you still want to do something, then you convert it to an image and then again create it into PDF format. Or you put some password, you do whatever the things that you want. But today the technology is so advanced and then you can still convert. But it is not straightforward. It's not straightforward. Even here it is the same thing. But here you are dealing with a sophisticated set of data. You can't make manipulations the way you want. Just by seeing the picture on the screen, you can't confirm that my changes are perfect. There might be something wrong. And when you get the finished product, then only you realize that it's too late. And it goes like that. And the synchronous technology, now you see the blue color one on the bullets on the right hand side, few options to change imported geometry. Of course, you can say except those direct editing tool which was introduced much later. Flexibility decreases as your design progresses. Flexibility that I talked the other day is highly flexible. Yes, when the number of features increases, the flexibility is going to be a problem. How to manage this flexibility? I mean, flexibility might increase, but to achieve that flexibility, it might be almost impossible. And the complex models are exceedingly fragile. Fragile means it will fail. Complex models. It depends on how you model this one as well. If you are a very experienced feature-based modeler, where you follow all the techniques and then you guidelines and everything is there, maybe you can have some hopes. But if you are just a beginner or maybe intermediate user where you don't have much experience and also you don't care about what you model, you see the finished product, then the problem starts. Whereas synchronous technology, the best of both worlds means the feature-based modeling and the synchronous modeling. So direct modeling in contrast to the feature-based modeling, offers few constraints. You can create and change whatever the geometry that you would like to have. Just selecting and then pushing, pulling, moving, rotating, everything like that. But only problem is it's going to add one more feature into the feature tree. You're hiding one you did earlier with another one. Right? It's not completely removing that. It's not you are dealing with the like this. Maybe in a way you can say it's going to be patched up and then create another one on top of that. So with this direct modeling, you can see little design intelligence and manual complex changes. Sometimes the changes are complicated. It depends on the model and the lack of model organization and intent. You see now, not like in the feature-based modeling, when you add from here and there these direct modeling features, it's going to be very complicated. You will not be able to see what the actual product is, and weak dimension driven editing. Right? Because you are not going to create any dimensions as such like in the feature-based modeling. So the solution is the synchronous technology where you can access both. So the picture I showed you the other day, synchronous technology is the combination of hybrid or the direct modeling and the feature-based modeling, history-based or the direct modeling, considering the best part of both these things, right? And also you have some exclusive functionality only available with the synchronous technology. So consider this part again, right? So let me show you how to create this part as a synchronous model. You see the tree over here, the path finder, the ordered part is gone and then synchronous part appears. You see some changes are there. Can you identify those changes? You see there PMI is opened and then you can see some dimensions. There are possibly 3 dimensions over here and you can see those 3 dimensions already appear. And then the base and other things are almost the same. The design body is still the same and you see the feature, the box one. And then you have something separate called the used sketches. The sketch tree has been used to generate the box and after that there's no use of that one. So they put that one into the use sketch mode. If you want you can recover that one, but even if you delete, nothing will happen to the part. Nothing will happen to the part. So let's see now. Before we come into that one, I'll just show you what does it mean. You see here there are no such thing. And if you say the PMI is also not here, right? So let me open a new file, which is going to be same as previous. Maybe I'll say ISO, maybe isometric part. Now, first thing I should do is I need to change this order to synchronous. I'll select this one and then transition to synchronous. You see the interface has changed. The PMI, another thing has not come. Only thing is the synchronous word appears over here. Look at the interface. Look at the interface. I'll go back to one of our previous parts. Maybe let's say part 1. And look at the interface. You have a sketch tool here. If you click only the other things will appear. And then extrude, cut and all these things are active. And if you go to this one, you see extrude, revolve, other things are not active except the box and maybe some other tools. And you can see all your sketch tools are accessible straight away. All your sketch tools, there is no need to create a separate sketch over here. So I can start with a box, for example, or else I can start with a sketch, right? Let's try to start with a box. So these are primitives actually. You see box, cylinder and the sphere. Those are very simple things. I'll start with the box command. I click. Yeah, maybe I click here. You see now the thing is also different. Right? You have the box created method. How to do this? You're going to create a rectangle and then extrude it. Right? So the creation method for the rectangle is by center, 2 points or by 3 points. Then you can have even a slanted rectangles. I'll select by center. Say extrusion to both sides. Those things you can always change like in the previous case. And also key points, we can say you can select onto different endpoints and other things. I'll pick maybe the endpoint because I want to snap onto that one. And when you take your cursor, remember I did not select any sketching plane or even a surface, nothing. Right? I straight away start creating a box and nothing much even in this dialog box. So when I move the cursor close to this one, you can see there's a padlock. There's a padlock. So if I want to create this one on this one, it is okay. But what will happen, say for example, I want to create that rectangle center line with the origin point. So if I take the cursor close to that one, it's going to switch my sketching plane. Can you see that one, the blue color one? Blue color one is the active one. Even if I go there, that's not going to work. So for that, you can see the lock function. You can press the function key F3, or else you can see, just click on that. You see that plane locks. Now I can move the cursor, nothing happens. Nothing happens. Understand? Right? So maybe I'll create on this plane. Now I'm going to see all these things. Now you can see, you can right click and see what options are available. I'll create here and then create it like this. You see the dimensions. If I want, I can change later. Otherwise, remember other tools I'm going to use. Click here and then drag it, and you can see you can change these things, symmetric, right? Symmetric. All these things you can use, right? And maybe I'll just say maybe to front side. Click here and then done. You see all of a sudden the PMI appears, box 1 appears as under the features, and if I select this one, you can say there are dimensions created. 3 dimensions are automatically created. You see, maybe I just turn off for the time being the reference planes. Can you see those dimensions? Are straight away created in the 3D model. Straight away created in the 3D model. So if I just double click here, I should be able to change this one. Say for example 100. How do I change? Because I didn't select any references. And say for example if I 75, I'll make it 80. Now again, just below the dimension, can you see some arrows are there? One in the middle is highlighted, means it's selected. Means a change will take place to both directions, assuming what you call the symmetry. You can go up and see another dialog box over here, which is called your design intent. Completely different from what you see in the feature-based modeling or the history or the modeling or in solid edge ordered modeling. Right? The software can maintain the design. I can clear this one. Okay, don't maintain anything. Right? Or else I can enable. Or I can choose even. Or even I can go further. You see, it's going to be more complicated than this. Right? More complicated than this. So let's try by changing this one into both sides. I'll make a, for example, big change. Maybe I'll say 50, something like this. Enter and see is going to change from both sides. Right? I'll double click here again. I want to change onto this side. You see now, I want to middle. I want to change onto this side. I'll try first this one. Right? Let's say this is already selected. I'll make it something like 120. Yes, 120. You see what's going to happen. Enter. Maybe I will upload this again. Maybe I'll remove this and then click here. I'll make it something like say 80. Right? It's only from that side. And then again, I just double click this. I'll remove the design intentions. Don't maintain. And then if I apply to this side, so maybe okay. I want to modify this onto the other side. I'll say again 120. Enter, and you see it's going to update into that side. Right? Bit complicated until you get all these things, right? Until you get all these things. But this is what you call synchronous feature is already applied here. I started with the box command. Now you see the extrude command, the revolve command and everything is active right now. Why is that? Why is that? Because you can select this face and then create extrude command. You see? Right? Or else you can have a sketch on top of this and you can create it. So for example, you want to create a sketch, maybe a revolve command or whatever it is. You see over here? Select this or maybe a revolve. Or else you can straight away click on the revolve button. Select this one. You see? Click that. That is this part. Right? Maybe you can try right clicking. Right? And then the axis you're going to define. Maybe I'll say the axis is here. Right? Axis may be somewhere here. You can try to create this one. And then you can see it is going to create like this. You remember this one again in what you call the history-based modeling or the ordered modeling in Solid Edge. Right? And I can define the value here. Say for example, this is, I would say something like 90 and then tab key, it will fix it and then apply. You see? Live sections, the thing has already appeared here. This is what the live section means. Right? So let me change this one. Say I'll change this one to say, how much was the other one? 50. I'll make it 75. Right? Into both directions. Enter. Something like ordered modeling. It's going to change that one as well. Maybe I'll change the height. Now again you see it has both directions. I'll make it something like 25 in both directions. It's going to update it again. Now you see what has happened. Still the model is active, right? No problems and everything like this because I changed this one to both sides. But remember, I have taken the live section from this point. If you undo this and then apply this change to the other direction, right, maybe to this direction, right, and then say enter, it goes like that. You can see it even exaggerating, but still it is active. Or else maybe I'll cancel this, double click this and then apply the change to the opposite direction, right, and then enter. You see it remains, right, but the model is still active. The model is still active. Okay. So maybe I will do a simple thing. For example, maybe let me delete the last protrusion. Revolve things we'll make it later. Right, say delete. And you can say the live section still remains. I can say delete the live sections as well because I can reuse that one. And you see what has happened to this 25 and other things, right? The more important thing in this one is how to use this steering wheel. This is the key to make changes to the synchronous models. I showed the very basic difference. Right now, this is where you're going to put much effort to understand this. You see, now all these things are different functions, and the way you select, you can say the left mouse button and only the left mouse button. First one is plus dragging, and the left plus the shift click, left again the shift and drag. You see, there again itself we have 6 combinations, and altogether there are how many? 6 different controls over here, and then 6 times 6, 36 different operations you have to remember like this, which is not easy. Only way through is the practice. Only way through is the practice, right? I'm not going to make it too complicated. You see, in order to change, swap the primary and the secondary axis. I'll show you what the steering wheel means, right, in a simple manner. Right, I just click on this face. The steering wheel appears. Actually, this is a 1D steering plane, and there's a 2D steering plane as well, steering wheel as well. Design intention, maybe I want to maintain. We'll come to those things later. So if I click and drag on from this, you see I can straight away modify this one. Now the full 3D the steering wheel appears. I can click on the middle point here and drag it and place it somewhere else. Right. So what did it says? I said shift and click. Right. You can click over here. You can switch. Can you see? It's going to change. Have to be careful. Right. So this there's the plain color thing. Right. You see, you can change. And then if you click from here, you can even change the angle, change the rotations, right? So let me change this one again, maybe to something like this, right? And then drag it and then place it over here. Somewhere here you can place it. You can say even here, doesn't matter. Okay. And after that, okay, I'll show you like this. I'm going to click on one of these circular parts and then make a small turn like this. Can you see? This is what is synchronous modeling is all about. I'm not worried about this, all these things. And then just click and then finish. Right? You can do a lot with the steering wheel and everything like this. So let me show you now how to create a sketch also, for example. Now I'm going to create a sketch as well, right? Maybe a circle. Now you need to select a sketching plane. I will just select. You can see I can lock onto that. Just say the function key F3, it locks. Now it is there. Right? Now all what you need to do is you get the, what do you call this, oh no, my F3 is configured for something else. Right? I'll start again. It's, right? So just click. Without clicking, you can say locked. Right? You can go and lock. Now it is locked. Then you can go into what you call the sketch view. You get it like this, and then you can have a circle wherever you want. Right? And then you can go there, finish. And then right click. Okay. The sketch is already there. Then I'll say extrude command. Right? And then select this one. You can say all these things. Going to select the chain, single, whatever it is. You can select this one. Right click, and then you can create the extrude command. Okay. Now we'll see what's going to happen with the steering wheel. I'm going to select this face. You see the steering wheel is created. Maybe I can just drag from this one and then place it wherever you want. Right? Or else I just select on this plane, right? And maybe I can just freely drag it even outside, you see. That is possible. Maybe I'll try with the fillet, for example. A small fillet over here. Maybe you see it is partially out. Maybe I'll say accept. Then again I'll try to move this one. Remember this face. Remember this face. I'm going to drag it. Maybe just click on the middle button again. You can get the full thing. Or maybe you can just leave it as it is and then click here. And then you can see I can move with the fillet command. Right? And then select this face, maybe even with that face, or maybe the whole thing. Right? I'm not going to select the fillet, but I'm going to select that one straightforward, and then I'm going to turn it like this. Can you see? And then click. You see the feature list? Nothing else. Still the same thing. Still the same thing. Only thing is some dimensions will be added and they are visible. And if you want, if you are disturbing you, then you can just turn them off. Just turn them off. And here you can see the sketch that I have used to create this. And you see it is somewhere else right now. You see, it's not in this original place. And if I don't need, I can say delete. Or maybe I can restore, reuse, and then delete. Right? Maybe I say delete. The sketch is gone, but your product is still there. It's not sketch dependent, and you are doing your editing directly straight away on the model. So the best thing is first you have to practice the steering wheel, otherwise you start making your very complicated models, right? Likewise, there are a lot of operations you have to learn, right? And practice and remember, and the way you select and all these things you need to remember, otherwise it's going to be very complicated. Very complicated. Right. Any questions? Because the time is almost up. Will you be able to manage all these things? Again, do you think it is complicated right now? The first day or the second day I got some good response, but what will be the situation today? Yes? Yes? What is your response today? You feel it difficult? I'll just say only two things, right? Two things. Maybe I should not use this word, right? Okay, I'll just put these two. Don't select the third choice. How about your response? Still good, but only 33 students are here. Only 15 sponsors are there. Others are not in the class. That's the main problem with this online teaching and other things. Right? Anyway, I will show you what your responses are. 16. Let me have a glass of water first. Can you see? I can see that one, right? Okay. If the whole class is here, I could get a different kind of an opinion. The show is still not started. This is the trail actually, right? Show is not started yet. And we still have surface modeling and other things. Of course, I will not going to discuss it for this particular class. But remember now you need to model your gearbox, the gear wheel, the shafts, and then animations. Right? There'll be lot. There'll be lot. So don't forget to practice. Right? At my age, I can do that. If I can do that, why not you? Even there are some persons even older than me here, right? I know definitely he's going to follow all these things, right? If my age I can do that, why not you? Don't discourage, right? Don't put your step backwards. Only thing is practice. If you come to a certain level, then only you feel that it is easy. Okay, because the time is up, I'm not going to take you even more. Right, so from next week onwards, we will have our regular time in the course schedule. I think Dr. Lil, it's on Wednesday from 10 to 12, right?
Yes. Yeah.
Okay, okay. So we'll have only less time, but those things I will concentrate more on your design project, right? How to start developing your concepts there. I mean, start modeling, maybe starting with gear wheels like things, and then shafts, and then how to modify them, how to create gear meshes, see animations, simple animations, and see how they're going to work. All these things I will start, but at the same time I will use some time for synchronous modeling as well, because it is also important, right? So if you don't have any questions, maybe I can stop the class today. There is one chat. Okay, it says thank you.